Hello everyone, welcome to CISA This Much. This is Aditya, and today we'll be discussing the amendments on domain number 1 from the 28th edition CISA review manual. So as we all know, on 1st of May, ISACA they have launched a new version of their CISA review manual, which is the 28th edition, right? The good news is that we don't have much amendments. We don't have a lot of amendments. There are new topics which are added, especially and mainly in domain number 5, and some minor changes in other domains. But overall, the amendments are not too huge. That's a good news. And this is something which we have already done the predictions almost 6 months back. I have already told everyone how much would be the approx changes in the new version, and it came to be true. So that's a good thing. So in domain number 1, in this particular lecture we'll be discussing the amendment from domain number 1 in this review manual. So basically, I'll be covering each and every amendment from each and every domains. So each and everything whatever newly is introduced in this review manual 28th edition, we'll be discussing each and every aspect, right? So under domain number 1, what are the changes? What is the new topic? So in this topic of 1.8 audit data analytics, they have introduced a new subtopic. So previously, till your 27th edition, we were already having the 1.8.1 till 1.8.3. These three topics were already there in the previous review manual as well, which is about the data analytics, which is about the cat tools, right? So in this particular new version, they have introduced artificial intelligence and machine learning in IS Audit. So 1.8.4. This is a new topic in this version, and here we'll be discussing audit algorithms, interpretation of AI ML results, and audit risk and consideration with regards to AI ML. So this all these things we will be discussing in this particular domain with regards to the amendments. But for this particular domain especially, I cannot just discuss about artificial intelligence alone. We'll need to discuss everything. We'll also need to discuss about the cat tools and the AI, because understand one thing, this particular topic 1.8.4, it might sound that this is just a new subtopic added, but no, it has got all the link with the earlier subtopic. So to really understand 1.8.4 with examples and everything, we will have to understand and we'll have to discuss about the previous things as well. So in this particular lecture, I'll not be just discussing about 1.8.4. I'll be discussing about everything, from 1.8.1 till 1.8.4. So everything would be discussed. So if you are in the old syllabus, okay, even you can watch this lecture. I mean, you can just skip the 1.8.4 part, because I'll be dealing with this topic in the end, towards the end, because the initial you can say 50% of the discussion would be with regards to the earlier the other 1.8.1 till 1.8.3, and the next 50% would be the discussion on 1.8.4. So in case you are giving the exam in the old syllabus, you can also watch this lecture. And also one more thing I would like to add over here is that in case you have plans to give the exam maybe like after mid of July, maybe third or fourth or end of July, you I mean, it makes sense to go through this at least for domain 1. It makes sense because they might ask you one or two questions, because uh, it is not that they don't have right to ask you questions on this topic, because this is an industry trend, and you are expected to know about this kind of change. So uh, especially for people who are planning for the end of July, they can watch at least for domain number 1, because this change is an important change for you to understand, right? And it's not difficult, to be very honest. It is something which everyone understand, but we will still need to discuss how this is linked with the audit, because artificial intelligence, we all have been discussing every now and then, but how it is linked with the auditing, that is something which we will have to learn, that is something which we'll have to discuss here. All right then. So without wasting much time, let's proceed ahead. So the exact amendment flow, first we'll have to discuss, the traditional way, the manual audit, and then we'll have to discuss the need for continuous monitoring, because from manual audit there was a term which was derived, which is continuous monitoring. From continuous monitoring, a new term derived, which was continuous audit. And from continuous audit, we have something known as AIML, which is nothing but the evolution of CAT tools. What are CAT tools? Computer assisted audit techniques, right? So in fact, in the review manual, you will find this exact sentence, which is AIML techniques are an evolution of computer assisted audit techniques. And this is something which is very important. That's why I've told you, we cannot discuss this topic alone, we'll have to discuss this topic with the CAT tools, okay? Because to understand the role of AI, to understand how it is helping in the entire audit life cycle, in the entire audit phase, we'll have to actually understand the role of CAT tools and what used to happen even before the even before having CAT tools. So manual audit, from manual audit, the second wave, which was CAT tools, and the third wave is the role of artificial intelligence. In fact, this is a diagram. This diagram is not there in the review manual. I have drawn this to help you understand how this amendment is interlinked. Because you cannot just learn about the third wave unless and until you actually understand, and actually if you can appreciate how the things have evolved, and how this particular emerged, and how this is interlinked with the other phases. So the first wave, okay, this evolution, the wave was paper supported audits, the manual audits, right? And the second wave was of having tools, CAT tools, computer assisted audit tools. And the third wave is the role of artificial intelligence in IS audit. Okay, now artificial intelligence is not something new. Okay, understand one thing, like if you do a Google search on Wikipedia, you'll understand, you'll find that the concept of artificial intelligence was born back in 1956, at some conference in some US college. They derived this particular term where they were very excited about creating machines that could mimic human intelligence. Okay, and also we need to understand that AI is definitely not a one time event. It's a field that is constantly growing up, and it is continuously changing. Think of it like a tree that keeps growing new branches and leaves. You know, I mean, honestly, AI isn't just about creating new products from scratch. It is, it's more like giving existing products superpowers. uh, think of example of using Excel, Word, PowerPoint, MS Office. We are using these tools since a long time, so many years. But artificial intelligence, it is what it is, giving these tools additional features, additional you can say superpowers. Okay, so artificial intelligence it's not a unique product in the sense, I mean, it is helping the existing products, existing solutions, by enhancing its features, by enhancing its capabilities, right? All right. So even like we have like everyone knows about this thing. We the Chat GPT, when it was introduced with the early version. Okay, that version was the first version was good, but the newer versions have become even more better and understanding and responding to your questions. Don't you think so? Right? In fact, even the self-driving cars also, the early versions needed a lot of human help, but they are getting better day by day. So understand, artificial intelligence is ever growing. You cannot say, okay, we have got into this third phase. this third phase is also will be, it will be growing every year. So new and new things will come, right? And honestly, like as of now, most of the companies are still like somewhere here at this particular point, right? And there's still a lot more to achieve here. See, understand one thing, nowadays IS auditors, more than data analysis part, they are spending more time in the data collection part. You know, I mean, maybe things are changing now, but still, if you look at audits, both maybe the financial audit or the system audits, most of the time, the auditors' time is spent on data collection, while actually the auditor should be spending more time on analyzing this data and interpreting whether the controls are in place or the controls are not in place. Don't you think so? Okay, so they are spending actually more time in the data collection part because they want to collect complete data, they want to collect correct data, they want to collect data from different sources, that it looks as if the entire audit process is only towards the data collection, data collection, data collection. We also rely on the auditee, the management, for giving us the data. So rather, the our professional skills should rather be more utilized towards the data analysis rather than the data collection part. In fact, you know what? When we'll be discussing about the third phase, the third wave, which is the role of artificial intelligence and machine learning, we'll be also discussing, the examples and how this can help you in each and every audit phase, in each and every part of the audit life cycle, from right from the planning to field work, documentation, reporting, follow up. In each and every aspect, in each and every phase, we'll be discussing the role of AI, how it will be assisting you. Because your time, see, understand, there are people who get scared when we discuss about the AI tools, and then they have these kind of thoughts that because of artificial intelligence, our job roles, our jobs will be going away. But it's not like that. Your focus will be changing from one aspect to another aspect. Okay, when it was manual audit, your focus was into something different thing, as what we're discussing about, more from the angle of data collection part, right? And then things got changing, when these kind of tools came, computer assisted audit techniques, so they then the responsibility of the data collection part, that got shifted to these tools, right? And now even analysis part, the data analysis part, in fact, how, in each and every phase of audit phase, in each and every part of the audit life cycle, how the AI would be assisting, we'll be discussing with the help of example. In fact, this is been given in your review manual as well, with examples in each and every phase. So understand one thing, it is not that when these kind of tools will come, your duty will go off. No, it will go away. No, it won't happen like that. Your focus will be changing. So if you're focusing in one area, you'll be focusing in other areas, right? All right. So as I've told you, we'll be discussing first the previous phase, which is 1.8.1 till 1.8.3. We'll be discussing these first, and then we'll be going for the new topic 1.8.4, right? All right. Just a minute. All right. So before discussing about the term continuous monitoring, the need of continuous monitoring, then we have the term of continuous auditing. Why this particular term of continuous auditing came? We'll go back little bit before this particular phase. So I'm talking about the first wave when we were having the manual audits. So that time the businesses used to happen during the fixed working hours. But understand one thing, and this is something which I don't need to explain to you everyone. This is something which everyone knows. Right now, businesses runs 24 by 7. Gone are the days when we used to have fixed office hours, fixed business hours. The transactions are happening during the midnight, 24 by 7. If for example, we have our portal, CISA.com. If someone wants to purchase, they do make transactions even during the midnights. We do get orders, right? So understand, from aspect, and honestly, I'm not just talking about the e-commerce and the retail industry, because e-commerce and retail industry is something which everyone knows about. The best example which I always give is of Amazon. You can make order 24 by 7, right? And even the processing of order, that also happens 24 by 7s. We get SMSs, we get messages from Amazon that there are times when the even the dispatch happens midnight. We get dispatch information midnight. And forget about these giants like Amazon. Even the nowadays, even the smaller online stores, even they have their own automated systems for order processing, right? And this is something which everyone might have experienced, like nowadays, even if we want to talk to the customer support team, normally what happens is that we have to talk with the chatbot, right? So we try to explain our concern to the chatbot, and it will kind of spend some time with you, trying to answer your question, trying to resolve your query. And in case if it finds that you're not being satisfied with their replies, then in the end, towards the end, it will give you option. Are you satisfied, or do you want to talk to a agent? Okay, and then if you're not satisfied, then you will talk to the agent again. For having a discussion with the agent, you get two options. You can either discuss via chat, or you can discuss via call option. So what exactly things are happening? They are having this automated solutions, because 80% of their concerns normally gets resolved with just the chatbots, because only few people require the help or the assistance from the the what to say, a person, a agent sitting up somewhere. So most of the queries, most of the concerns are resolved just by these automated chatbots. So again, now forget about this particular sector, e-commerce. We can talk about various sectors. If we talk about, let's say, finance and banking, financial markets, everyone knows they operate globally. They never close, they never fully close. Customer require access to their funds and services at all times, right? Banks, they are offering online banking, mobile apps, 24 by 7 account access. Even ATMs, they provide the cash withdrawal 24 by 7, which is beyond the working hours of the branch, beyond the branch working hours, right? You can take the example of healthcare sector. There also, medical emergencies, the patient needs, so it's not a 9 to 5 schedule, right? We need continuous monitoring, right? You can talk about the example of maybe transportation and logistics. Again, food delivering apps like yeah, our Swiggy, Zomato, which we have in India, right? So we can order food. Even nowadays, they operate entire 24 by 7. I don't know about other cities, but in Mumbai, where I'm currently staying, I mean, I do place orders even during midnights, 3 a.m., 3:30 a.m., right? So understand one thing, uh, businesses, they are running 24 by 7. So if you look at the screen, what I'm trying to say over here is that when the speed of processing increases, I mean, the speed of processing is increasing, the rate at which automation happening is rapidly increasing, right? Businesses are running 24 by 7. When this is happening 24 by 7, don't you think so? The chances of errors and frauds will also increase at the same speed rapidly. If businesses are working 24 by 7, errors and frauds can also happen what? 24 by 7. It could be any error. It could be hardware failure, software failure. It could be network errors, network failure, server crashes, right? When this is happening 24 by 7, this should also, I mean, this can also happen 24 by 7. When there is a chance of errors happening 24 by 7, don't you think so? We need controls 24 by 7. We need controls. See, one thing is common over here, which is 24 by 7. So when the chance of errors and frauds happening is 24 by 7, there is a need for having control also 24 by 7. For example, in case of ATM, let's say the bank branch working hours is 9 to 5. You cannot just say that the controls maybe, see, when you get inside any ATM, there will be what? There will be CCTV cameras, right? And then you have what? Card based controls, pin based controls. You must be having card, you must be knowing your pin, right? So these kind of authentication happens, right? So these controls should also work 24 by 7, right? You cannot just say that bank branch working hours is 9 to 5, so the controls will only work 9 to 5. No, right? In fact, the bank branch working hours is 9 to 5, but the transactions, the business is running 24 by 7. So when businesses are running 24 by 7, controls should also work 24 by 7. When controls should work 24 by 7, don't you think so we should monitor the control also 24 by 7? Are you able to understand how this term got arrived, continuous monitoring? When controls are working 24 by 7, how do you know whether the controls are working 24 by 7? There can be a chance that the controls stopped working, right? How do you get to know that? In other words, you can also ask this question that when the control fails, how soon you will get to know that the control has failed? Okay, you will only get to know when there is what? When there is continuous monitoring of controls. Continuous monitoring of controls. In fact, continuous monitoring of control is the responsibility of whom? Auditor or auditee? Think upon it. This responsibility of continuous monitoring is lies with the auditor or with the auditee. It lies with both, right? But in this particular scenario, when you talk about control monitoring, ideally the first person to continuously monitor the control should be the management or the auditee. That's what we discuss in control self assessment. So auditor will do his duty, but then it's not that if audit is happening you can just sit relax. The management is not cannot just sit relax just because the audit is happening. So even if the audit is happening, you still need to continuously monitor your controls, and that is the duty of the auditor auditee, the management, right? Now, when continuous monitoring is happening, now can you really think, can you really have manual audits? Can you really have manual audits? No, right? Understand one thing, the amount of data, the amount of logs are being generated every day. Can you really audit, manually? No, that is not possible, right? So there is a what? There is need of automated tools for continuous auditing. There is a need of continuous audit, and for continuous audit, we need what? We need automated tools. Okay, understand how this term got derived. Okay, when this is happening 24 by 7, this is also happening 24 by 7. Okay, we need controls also 24 by 7. When controls are needed 24 by 7, we also require to monitor the control 24 by 7. When everything is happening 24 by 7, we also need to have what? Continuous audit. Now this continuous audit is for auditors, right? So audit should have also happen continuously 24 by 7. But this can also not happen manually, right? So we need what? We need some kind of automated tools. We need some kind of assistance. We need some kind of software. And this is nothing but we are talking about the CAT tool, which is computer assisted audit techniques. I hope you are able to understand what exactly do we mean by this term continuous, computer assisted audit techniques. And because you need to understand, see, if you look at this manual, there is a term of what? They have used a term of continuous auditing and continuous monitoring. These two terms are used, and it's very important, right? And because if you don't understand this, honestly, you will not be even able to understand the artificial intelligence and the need of it, right? So If you want, you can just take down some notes. Okay, but the discussion is not yet over, right? So most of the online transaction processing systems are working close to what, 24 by 7, 24 by 7, right? So which means that the hardware components, the software components, the network components, the everything should also ideally work 24 by 7. Okay, for example, let's take an example of maybe hospital management system. Okay, it's very very critical. Financial system, financial payment system, very very critical to the economy, right, to the bank, to the customers. If there is a delay or there is a latency or a downtime, they immediately send out an alert with these online monitoring tools. Okay, so, in other words, today almost the entire IT infrastructure, whether you talk about the network, hardware, database, websites, web server, everything should be monitored what? 24 by 7. Okay, I'll also give you one example, one simple example, because I don't want to use very difficult examples. In my case also, our website is cisadismuch.com, right? So we also have what we have something known as continuous pinging, continuous monitoring. So whenever, okay, when the whenever there is a downtime in the web server, we immediately get notification or alert, because I cannot just rely on the customers to tell me. Okay, first of all, customers, they are least bothered. They're not going to tell me your website is not getting opened. Nowadays, with this competitive market, let's take example of maybe e-commerce and retail industry. If a particular website is down, you'll not be bothered to notify the relevant people. Rather, you will go to some other website. You'll not care as a customer, right? It is the duty of the management, it is the duty of the company, it is the duty of the organization to continuously monitor all their IT infrastructure, right? So this is what is mentioned: 24 by 7 business, 24 by 7 CIA. CIA is what? Confidentiality, integrity, availability. Now, since we are in domain 1, and if someone is watching domain 1 right now, okay, and obviously you should be watching domain 1 initially and not domain 5, because CIA term is discussed in depth in domain number 5, which is confidentiality, integrity, and availability. In simple words, confidentiality means unauthorized disclosure of information should not be there. Integrity is unauthorized modification of data or information should not be there. And availability is unauthorized withholding of information or data should not be there. Even if you don't understand, it's completely fine, because we have discussed very in depth in domain 4 and 5. And as of now, you're not supposed to know all these things, because we are in domain, we're discussing about domain number 1, right? So even though this is amendment lecture, but still, obviously, if someone has not gone through domain 5, they will not be able to really understand. And honestly, it doesn't even matter as of now. Okay, so example I have written over here: continuous network monitoring, continuous server monitoring, timely backups, etc. Okay, then here it's mentioned incidents, failure of IT components, security. Again, incident topic. It's discussion domain 4. It's not required over here as of now. I mean, you can just delete this, because unnecessary. It will just confuse you, and it's not the matter of discussion over here. So you can just remove it. I just mentioned for the example part. I mean, you can just remove it, because we have already discussed in domain 4 and domain 5. Okay. So, continuous auditing should be independent of continuous control or continuous monitoring. Now, this is a very beautiful line given, in your review manual. Continuous auditing should be independent. You will, it's very important to understand this entire, line, because if you don't understand, you will honestly not be able to understand what do we mean by continuous assurance. Okay, now, as I've told you, there is auditor, and then there is what? Organization, the company, or you can say the auditee, right? Both needs to do their response, both needs to do their roles. They need to work on their roles. They need to have their own responsibilities. You cannot just say that auditor will do 100% activity, we can just sit idle and we can just sit relaxed. No. Okay, both auditor as well as auditee, they have their own set of responsibilities, right? So, as we have discussed above, continuous monitoring lies with the auditee, the organization. Continuous monitoring, in fact, this comes first. Continuous monitoring comes first. Continuous auditing will come afterwards, right? I mean, when I'm giving you the the sequence of derivations, but honestly, this two things should work, simultaneously. Continuous monitoring as well as continuous auditing. Okay. Now, auditor, they are supposed to do what? Continuous auditing, and that's why they have told this thing, that continuous auditing should be independent. Okay, it should be independent of continuous control or continuous monitoring, meaning, in other words, continuous monitoring or continuous control should be done by the auditee, and continuous auditing should be done ideally by the auditor. When these two things happens together, then only we can say we can give continuous assurance, we can have continuous assurance on the controls and the processes of the organization. So continuous monitoring plus continuous auditing is equal to continuous assurance. This is the very important formula. I hope everyone have understood till here. Okay, so before going ahead, if you have any doubts or anything, you can just go back again and have a quick revision of this. Okay, all right. So the next thing is these CAT tools, computer assisted audit technique. These CAT tools do not replace the audit planning, do not replace the audit process, do not replace the audit phases, do not replace the audit life cycle, do not replace the IS auditors. So basically, these tools will just facilitate or will just support the IS auditor in the entire audit phase, but it is not going to replace them. It is just like, in uh, airlines we have something known as autopilot, right? Now the time from when the plane take off till the time the plane lands, almost, you can say 70 to 80% of the tasks are handled by the autopilot. But that doesn't mean that the human pilot is not required, right? In fact, all the major decisions, all the critical thinking, all the emergency decisions, each and everything are taken care of by the human pilot, right? He is the main person. So just because we have the autopilot, so autopilot is not replacing the human pilots, right? It is just facilitating, it is just supporting the pilots. Similarly, here also these tools do not replace the auditors, it just facilitate, it just support the auditors. So what to review, when to review, how to review, all these things still remain the same. In fact, they also say that the audit tools is only as good as the IS auditors. Again, I'm repeating. They say the audit tools is only as good as the IS auditors, meaning that, to get the best optimum utilization from these tools, it all depends upon how effectively the IS auditors use these tools. So it all depends upon the right skills of the IS auditor. So how well he can utilize these tools, it all depends upon the auditors, right? So these tools cannot just replace the entire audit life cycle, entire auditors. Uh, this is the important thing, right? So the next thing which we'll be discussing is, when you say these CAT tools, we can say CAT tools mainly are of two types, which is the external audit tools and the something known as internal audit tools or the embedded audit modules. Okay, now what is external audit tools, what is embedded audit modules, we'll be discussing each and everything one by one. Okay, uh, external audit tools, as of now just remember the names. Okay, what does it mean, what role it will play, and everything will you'll be having idea very soon. It is also known as gas. Gas is nothing but generalized audit software. The full form of GAS is Generalized Audit Software. All right. So external audit tools or the generalized audit software or the embedded audit module. These are the mainly two types of the CAT tools. Okay. Now, when you say generalized audit software or the external audit tools or the external audit modules, what exactly happening here is that the auditor, they themselves are bringing in the software. Okay, now this software they are using it at multiple client places. Okay, so this software is with, I mean, the auditor, they themselves are bringing in. Now here what happens is, okay, the auditors will ask for the data from the auditee, from the management. So what will happen, the data would get exported from the auditee's software, from the auditee's application in a format which is understandable by the these generalized audit software, by the external audit tools, and then these data would be imported into these software. Okay, so first it would be exported. So here you can see, here is export and import. What happens over here is that, okay, now there is something known as direct access also, but we'll discuss about that afterwards. As of now, when you say generalized audit software or the external audit tool, what exactly happening is that you are exporting the data. I mean you are getting the data exported from the auditee's software, from the management's software, and then those data are imported into these software, and then the analysis happens by the auditor. So here what is happening is the auditor, they themselves are bringing in the software. Okay, now in case of embedded audit modules, the thing is opposite. Okay, in case of embedded audit modules, what is happening is that instead of you bringing in the software, this audit module is already embedded, it is already attached, it is already fixed. Embed means attached, embed means fixed, embed means it is with the application, the client's ERP or the client's SAP or the client's application software. So let's say if this is the client's application software, what we are saying is that the we also want audit module to be attached by default. Okay, but by default audit module is already embedded, it's already attached, it's already fixed with the client's application software. We'll be again discussing, don't worry if you're not able to understand this, because this is slightly linked with the domain 3 area. Okay, so don't worry about that. So as of now, the first thing which we'll be discussing is the external audit tools or the generalized audit software, wherein the auditor, they themselves are bringing in the software. And the first one which I have discussed with you is export and import. What happens here is that, so the data is extracted from the ERP systems, example SAP, into a common file format that generalized audit software, they can easily understand and process. It could be maybe CSV file or Excel file or text files, right? So these data would be exported right from the auditee's ERP or the client's software, and then it would be imported into the generalized audit software. The auditee, the company being audited, would typically generate these exports from their ERP system, and the auditor would then import them into the GAS tool for analysis. And the benefits is more universally applicable, less reliance on technical setup. Okay, because there is, I mean, you don't need integration with the client IT environment, right? Here, in case of export and import, basically you are having your own independent software, and you don't need to integrate that, or connect that with the client's IT infrastructure or the IT environment, with the client's database, with the client's applications, right? You don't need that. So it is potentially simpler for less tech savvy auditor, right? Challenges introduces a manual step here, right? So here it's a manual step, export and import. Potential for errors during the data transfer, and may not be as efficient as the direct access. What is direct access, we'll again see. Technical feasibility, okay, now this part we'll be discussing afterwards, right? So next thing is that not direct access and is export and import, both are part of the external audit module or the generalized audit software. So as of now, I'm discussing this part only, this first part only, right? What is embedded audit modules, we'll be discussing afterwards, right? I just gave you the overview of what exactly do we mean by the word embed, to attach or to fix. right? But we'll be discussing that afterwards. So as of now, when you say direct access, even that is a part of what? External audit tool, right? In case of direct access, what happens is that the gas connects directly to the ERP systems database using a specialized connector or the API. This allows for real-time or near real-time data analysis within the gas tool without the need of manual export. So here you're basically trying to integrate. Okay, it will not be deep integration, but then you still require to a specialized connector or the API to integrate with the client's IT environment, right? Now, when you say integration, whenever this word come integration, it involves risk, right? So because client, they have a lot of sensitive information which if gets leaked out, it can create a huge impact for them, right? So I mean, here for this particular part, definitely you will require what? Specialized permission from the clients, right? And that's why I have mentioned over here is that there can be what? Permission issues. Okay, so client may or may not allow, because most of the large organization, they consider this as a risk, right? So definitely, we'll need to take we'll need to get full permissions for this to be done for getting the direct access, right? And also there can be sometimes integration issues also, right? So because since here, even though it doesn't require deep integration, but then at least we need to connect it, right, to get without the need of the manual efforts if we want to get the data. Okay, so it requires integration, so it can cause integration issues also with the IT environment. So these are the two things because of which we normally say that we should try to get for the embedded audit modules, because this particular thing, embedded audit modules, this gives us lot of information as compared to the external audit tools. But having said that, even generalized audit software, this is also a very good tool to use, if you want to get access without doing much of the integration, or for the client or for the organization if they do not have audit modules embedded, because embedded audit modules will not be there with all the organizations. It normally is there with large organization, but when it comes to the small organization or medium sized organization, in these cases they might not have the embedded audit module. So in that case, generalized audit software will be very helpful for you, right? Now, benefits for the direct access: efficiency, data accuracy, reduced manual effort, and potential for continuous auditing. Challenges: requires technical setup, potential security concerns, right? And which we have discussed. That's the reason the auditor or the management, they consider this as a risk and may not be supported for all the ERP systems or the versions. Okay, now next thing which we'll be discussing is the embedded audit modules, which is actually important and which will be discussed in depth afterwards, while we'll be discussing about the scarf and audit hooks and all those things. So we'll be discussing morely I mean mainly from this topic, which is the embedded audit module. So what is embedded audit modules? Embedding means, as I've already told you, embedding means attaching or fixing. So embedding means making it part of where it is embedded. Now when you say embedded, it is primarily attached or primarily fixed at the application level itself, which means that as a part of design. Just a minute, I think I'll have to show you something here. Hmm, okay, I can write here. Yeah, yeah, see, understand. Okay, so now I'm discussing something from domain 3. Okay. Okay. Now, since you are in domain 1, if you know about the domain 3 part, it's completely it will be good. But if you do not know, again, it's completely fine. You don't have to worry about it, because in domain 3 we have discussed in depth something about the entire HDLC, the system development life cycle, the software development life cycle, right? So where we discuss the need of having the requirement analysis, requirement definition, then feasibility analysis, then we have the design phase, then the development phase, then the testing, then the implementation, then the post implementation review. So what I mean if you know about this, it's good. But if you even if you do not know, it's completely fine. You will be learning in domain number 3. And you know what, this is actually what to say, the beauty of this certification, that all the five domains, they are somewhere interlinked, and this is where most of the students or most of the people, they make mistake, especially people who do not have prior IT audit experience or prior IT experience. What they do is that they finish a particular domain, for example domain 1, and then they start solving the official QAE from the domain 1, thinking that they'll be able to solve everything. But then while solving the question answers from domain 1, they come across lot of technical terms, okay, which they might have not which they might not know about, or which might be a term which is used in other domains. So when they come across these terms, they get stuck. So that's why I always say, if you do not have the prior understanding or the prior experience or the prior knowledge, it's always better to first go through all the lectures and everything, right? Because in the lectures, also you'll be we discuss a lot of question answers, right? So once that gets over, and then when you start solving the question answers, then you will be really able to appreciate the question, you will be really able to understand the questions, okay? So do not directly jump, because here also when I'm discussing this, it has got some links with the domain number 3, right? Now in domain number 2 also, we have discussed something known as, you need to invest in IT only when it is required by a business. Okay, meaning that in the IT governance, what we have told that even if you are if you're investing or if you're spending any money on the IT infrastructure, it needs to, you need to understand how what kind of benefit it will bring for your business, whether it will meet your business requirements, right? So all those things needs to be done. So in domain 3 we have discussed the same thing for the software thing, from the angle of software. So the thing which we have discussed in domain number 2, IT governance, invest in IT only when it is required by a business. Same thing in domain 3 we discuss with this particular phase, wherein we say that in case of softwares, in case of application software, when you're investing in application software, it needs to go through the requirement analysis phase of the feasibility analysis. Okay, whether it is feasible for you to go for that particular solution, then you will be designing that particular software, then you will be developing that particular software, then you will be testing those software before implementation, then you'll be implementing, and then there will be post implementation review. Okay, so whatever things, in domain 3, basically what I'm trying to say over here is that before investing, you do all those things. So now what I'm saying is that, so the way you do for your application software, you start keeping even the audit module in each and every phases. Okay, now in the system, like in the requirement analysis phase, you know with the requirement, like when you're having the discussion about the application software fulfilling your business requirements, also keep audit modules also as a part of the consideration. Having said that, what we're trying to say is, with your application software, okay, you will need to embed, you will need to attach something known as audit module. Okay, so it's okay, you are planning for having this particular software, and you are planning for all the phases, the requirement, feasibility, design, development. In all these things, you will also need to integrate something known as, you need to plan for even the audit modules. So audit modules should be by design itself. Okay, auditor, there should not be need of the auditor to bring in his own software. Okay, by default, when you're using any software, when you're designing the ERP, you also plan for the audit module to be attached, to be embedded as a part of your application software itself. This is nothing but the embedded audit modules. And when we say embedded, primarily it is embedded at the application level itself. Okay, which means as a part of design and development of an application software, we are suggesting that they design and develop an audit module also. Okay, we want the audit module also to become part of that application software, which means just like you build a software for business functionality, giving them the requirement specification, design, development, and testing, we are saying please give requirement specification, design, develop, and test audit modules also to be part of the some software, right? To be part of the application software itself. And if you're able to achieve this, we call this as embedded audit modules. Okay, now most ERPs have their own audit modules as a part of the application. They are primarily embedded at the application level. Some may be embedded at the database level also, but primarily they are embedded at the application level. Now, please note that these audit modules cannot work themselves. They need people to configure them properly. Just like you need somebody to configure your application software properly, they also need people to be able to interpret the results out of these audit modules. And they do not replace, as I've told earlier also, they do not replace an audit process. They just support an audit process. So if the application software, if the application, so when I say it is attached, so if the application software, if this stops functioning, the audit module also will stop functioning. If the application software is not reliable, it throws up a lot of errors, it restarts very frequently, consistency is not there, in that case even the audit modules will also have to suffer from the same limitation. Having said that, these embedded audit modules are one of the best mechanisms to track what's happening through an application seamlessly, which cannot be achieved either manually or either through external audit modules. So, embedded audit modules, it is much, much, much better than your external audit modules, because in case of external audit modules you need client permission. You cannot just import all the data, because understand one thing, a huge amount of data would be generated, lot of system logs, and like lot of amount of data would be generated, and it's not practically possible to input everything and do the analysis. But with regards to the embedded audit modules, it becomes very easy for the auditors to do the audit. So that's why what this will be achieving is it cannot be achieved either manually or through the external audit modules. Okay, now as I've told you, simply because an audit module is part of application, your job is not over, right? Simply because an audit module is part of the application, it does not mean that all the controls are working properly. You still need to know how to use these audit modules to generate the right kind of reports or information for you to confirm whether the controls are working all right or are not working all right. And if you're able to achieve all these things, it is called as the embedded audit modules. Now we'll be discussing in depth about this embedded audit modules, but I hope that you have understood the main difference between these two, and it is very important for you to understand this, right? So if you want to take a pause, you can take a pause, and then I'll be starting with the next thing, where I'll be discussing a lot of things like ITF and audit hooks and scarf and all those things, right? All right, so now we'll be discussing 5 types of automated evaluation techniques under the continuous auditing, which they have discussed under the review manual, right? So the first one which we'll be discussing is ITF. Second thing would be SCARF. Third one would be audit hooks. Fourth would be CIS, continuous and intermittent simulation. Fifth one is snapshot or extended record. Snapshot or extended record. So these are the 5 types of automated evaluation techniques. You can also say these are actually part of the embedded audit modules. These we will be discussing one by one in detail, in depth. All right. So the first one is the ITF, which is integrated test facility. I'll just note it down over here. Okay, so I'll just write here ITF, or maybe you can. I mean, I have given you the notes also for this, right? So let me open that. Mhm. Yeah, so integrated test facility. So we'll be discussing about the ITF first, right? Now, again, ITF is also something which is again interlinked with your domain number 3. Okay, and there also we have discussed about this particular aspect of ITF. Okay, now even if you don't know about this particular thing, or even if you have not studied domain 3, it's completely fine, completely fine, because I'll be giving you one example through which you will be easily understanding what is the relevance of this particular term, integrated test facility. Okay, now under domain 3, we always say that testing should not be carried out in the production environment or in the live environment. Okay, I'll give you one example, so that even if you don't know, or even if you have not learned domain 3, which is very much natural, we'll still be able to understand this, right? Okay, so in domain 3, we always say that testing testing should not be carried out should not be carried out in the production production environment or live environment. Okay, basically they are saying that keep testing environment separately. Okay, do not mix up the testing and the production environment. What does it mean? I'll give you one simple example, very easy example, through which you can understand, even if you don't have any prior knowledge about it. Okay, now let's say I'll give you an example that you are baking a cake for a big event or a function. Okay, let's say there is a function, there's an event, right? And and it's a very big event, it's not a small event, it's a big event. And they have given you this contract of making a huge cake, maybe 5 kg, 10 kg, I don't know, a huge cake. That order you have got, right? Now the event or the party or the function that is known as the live or the production environment, right? And then your kitchen is something known as test environment. Your kitchen is your test environment. And the main event, the function where people will be having a lot of expectations from you, because you have a lot of reputation in the market, and they have given you a customized order. It's not something which you make every other day. It's a customized special order for a special guest. It's a big event, big party, big function, right? And you have been given the order to make a huge cake. Now the event or that function is a live environment, and your kitchen, where you will be testing, where you will be making it, is your test environment. Now understand one thing, why we always say that we need to separate these two environments, is because, now understand, let's say if you are doing maybe the function is at 4 p.m., evening 4 p.m., right? And let's say you are building the you are making the cake, from the morning, maybe like 11:30 a.m. you started preparing that cake in your kitchen. Now if you make some mistake in your kitchen, you can rectify that, right? I mean you'll not be hampering the main event, right? Let's say if I mean honestly, when you prepare these kind of orders for a very big function, or for a big event, you in fact try to do R&D with your recipe even one day before the event, or maybe 2 days before the event. Don't you think so? If you get such a big customized order, you will be not making the full cake, but you will be just making a small portion of that particular cake, to just check for the taste, the softness, and the fluffiness of the cake. So basically all those R&D, all those doing trial and error method with your recipe, all these things will be done in a testing environment. You will not directly go to the function, maybe like at 3 p.m., and start building the cake. Or because if understand, if some kind of mistake happens right at the main function, it will be having huge impact for you, right? So whatever testing and everything, that would be done in a separate environment. In this example, maybe in a kitchen, maybe one day before the event, maybe 2 days before the event, right? Or even if at the same day, then also in a kitchen, in an environment where it is not hampering. Because let's say you are doing this particular stuff, R&D with your recipe in the main function event, in the main function of the main event, and you make a mistake. and the guest who has arrived over there, they understand that you have a lot of reputation or a brand name in the market, but you are still not able to make a good recipe, and you have done such a huge mistake, huge blunder while making this entire cake, or with the recipe part. So it will have a huge impact in your business, so that's the reason we do not mix up the production and the live environment. So production and live environment in this example was the main event or the main function where people are having expectations for you. Similarly, in the organization also, when we say live environment or the production environment, it basically deals with the customer part. Okay, and so that's the reason the testing is not done in front of them. Testing is done in a separate environment. This is the simple example with which you will definitely be understanding what I'm trying to say over here. And even if you don't have any prior knowledge about this part, you will still be able to understand, right? So what do we mean in this integrated test facility? So we have always been saying that the testing should not be carried out in the production environment, and that rule stands. Okay, however, in certain circumstances, you may not be able to create a test environment which is very, very, very similar to a production environment, or the process of testing in a test environment may be so cumbersome because the process is so complex, which mimics all the things that you see in a production environment, that can make this making a separate test environment very, very challenging and very, very time consuming. So organization thought whether we can carry out testing as a part of the live processing itself. Oh. So what they are saying is that when you say the word integrated test facility, the word you used over here is integrated. You are integrating the live or the production environment with the test environment, because for you, you are facing a lot of challenges, making a separate testing environment, or maybe the test environment might not test each and every aspect which you are having in the production environment. So what you are saying is that why not, whether we can carry out testing as a part of the live processing, taking due care to ensure that testing does not interfere with the live processing. Because understand one thing, that you cannot interfere, or the live processing should not get impacted. The example which I have taken with you, the example of baking the cake, you cannot impact the function of the event, right? You are doing a lot of R&D with your recipes, suddenly some unfortunate thing happens in that particular event, that should not be having impact on the other aspects of that function, or the other party, right? So you basically cannot disturb the live processing or the production environment. Okay, or even if there is an impact on the live processing, either the impact is very minimal, very negligible, or if there is an impact, the same is reversed immediately, so that the live transactions are not affected. And if you are able to achieve this, this is called as integrated test facility. Okay, even if you have not understood, it's completely fine. We'll be again discussing this thing with the theory part which I have given to you, right? So we'll be discussing the whatever I have discussed with you right now over here, same thing is written over here as well, and we'll be discussing again. Okay, again the same thing will be discussed in domain 3 as well. Okay, but do not worry, because I know for some people, if you don't have the prior knowledge, or if you have not gone to the domain 3, it might look slightly difficult for you. Okay, but basically what exactly we are doing over here is that we are integrating the test environment with the live with the production environment. Okay, why? Because of some genuine reason. Okay, in simple term, we are not able to create a separate test environment because we want to check each and everything. Okay, we want to let's say for example, in the, like, if I take the same example of that function of the event. Now there are 10 main relatives of that particular family. It's a big family event, right? 10, 10 major family members, and you want to make sure that all these 10 people are satisfied. Okay, now you cannot just do the R&D in your kitchen and expect that all these 10 people will give you the approval. So that will not be possible. Okay, maybe you can call one or two of them. They will come to your kitchen. They will taste the cake, and they will give you the feedback. But if you want to take all the 10 members, or in fact more than that, you will need to come to the live environment, and then you will need to give them the sample, and to make sure that whatever product or whatever cake you have prepared, that will fulfill the needs, that will fulfill the taste, and it will satisfy everyone. So for that to happen, you need to integrate this testing environment and the production environment. Okay, so I'm just trying to link that example so that you'll be able to understand what we are trying to achieve with this integrated test facility. Okay, now understand one thing again. When testing is integrated along with the live processing, it becomes very, 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 very risky. Why? Because if it is not done properly, or if it is not designed properly, it can have a huge impact. Okay, so what basically we are trying to say over here is that either uh, when you are having the ITF, integrated test facility, in your production environment, what you do, either you reverse the transaction afterwards, reverse a transaction whatever you have created as a part of the dummy transactions, as a part of the fake transactions, whatever you have created for a part of testing, you either reverse it afterwards, or you flag it. Okay, so for example, when you flag it, you can easily able to identify that this is a part of a testing transaction. Okay, it is not a part of the live transaction. Okay, so it is something different, or maybe if not, you either reverse a transaction after the testing is finished. Okay, so how do you achieve this? So I'll give you an example. So let's say we're an organization, maybe any organization which wants to test some products very frequently. Let us say you are launching a new solution for your customer. Let us take an example of a financial institution. Okay, let's take an example of a financial institution, a bank, maybe launching a new financial product, a microfinance product for its customer. Now, they will have to create a customer profile. Okay, you will have to input certain values for that customer first. Then you should be able to do some transaction relating to that customer, right? So you'll have to compute certain values for that particular product, maybe let's say interest or whatever. Now you can tell the development team as a part of design and development that, hey, look, as a part of this application development, you need to note that we need a facility by which we can enter certain transaction based on certain transaction codes or reference number. Like for example, maybe you can tell them, you can put a triple nine, I mean four times nine as a transaction code to indicate that this is not a live transaction. Or I may create a dummy customer account or a dummy customer entity with a particular prefix or a particular suffix, and the application software should be able to recognize this. And if it is able to recognize this, then only we'll be able to achieve our entire purpose. So we say that we need to ensure that the output of this processing does not interfere with my production data, or does not impact with my live transaction, or even if it does interfere, the same is either reversed immediately. The same is either reversed immediately, or you have flagged those transactions. Okay, so this is what we mean by the term integrated test facility. Okay, and why are we doing this? Because there was a challenge in the test environment, because there was always one question that used to come up in the when we are working in the test environment, that it is working well in the test environment, but we don't know whether it will work in the same way in the production environment also. Because the test version of the software similar to the production version of the software, I mean, we want to test that both the version, I mean, we are testing each and every aspect, each and every functionality of what we have in the production or the live environment. So as I've told you, for the example of the cake, we want to satisfy all the taste buds of almost all the important family members, right? and we might not be able to do that, in our test environment. So for that reason, maybe, we might have to come maybe at 11 a.m. or 11:30 a.m., in that function, way before, other guests will arrive, so that we will make that recipe and we will give the sample to the main family members and get their feedback and do some changes with the recipe of the cake, right? In case of integrated test facility, you can be rest assured that whatever output you get as a part of this testing is very, very, very close to your production environment, because you have actually done it in a production environment or the live environment. Also, there is one more thing we need to always ensure, that because testing is being done as a part of the production environment, there can be chances of slowdown of the process. There can be delay in processing that might impact the customer or the employees. And if this is happening, we need to take care that, this does not interfere, or this does not have a lot of impact on the entire production process. Similar to the example which I've given to you, if you are, coming to that particular function maybe at 11:30 a.m. or 12 p.m. or 12:30 p.m., way before other guest arrives, I mean, we need to take care that, our, R&D with this recipe and everything should not interfere with the other things, which is because when the event is at 4 or 4:30 p.m., there would be a lot of things, which would be happening in that particular hall, maybe lightings and decorations part and all those things. So we should not be doing the impact, our activities should not be having impact on the other things which are happening in that particular event. So this is what they are trying to say, that, because you are integrating both testing and the production, there could be a lot of issues. I mean, there might be chances that, it might try to, have an impact on the production process, or it might give, difficulty to the customer or the employees, so we need to ensure that this thing does not happen. Okay. And if you're able to achieve this, we call this technique as integrated test facility, ITF. As simple as that. Now let's, read out what we have mentioned here in the integrated test facility. You can also download these notes, by the way. Mhm. Just a minute. All right, so what is mentioned? What is an integrated test facility, ITF? A method of testing software changes or new functionalities directly within the live production environment. Used when replicating the exact production environment for testing is difficult or time consuming or complex. Okay. It helps to obtain the realistic test results while minimizing the potential disruption to the actual production data. I mean, this is our goal, that, we want to obtain what realistic test results, while we want to minimize what disruption to the actual production data, because there can be an impact on the production data, and our goal is always to minimize any kind of disruption. Our only goal is to get the realistic test results which is actually testing all the requirements, all the functionalities which we need to test with regards to the real production or the real live environment. Okay. Why the production shouldn't be a test bed? Okay, they say normally that production shouldn't be a test bed. Rule, this is the rule. Okay, production environment should not be a test environment, shouldn't be a test bed. Rule exists. Why this rule exists? Because risk of errors. Testing in production environment can cause unintended changes or data corruption or system failures, and it can also have impact on the users. The live users may be negatively affected by performance issues or unexpected behavior during the testing. If you're not able to understand, go with the logic of that event or the function. You'll be able to understand everything. And how ITF work? Okay, special markers. Okay, we test use dummy data, clearly marked. Example, transaction code. I've told you, we can use maybe like triple, 4 times 9, or 4 times 8, or 4 times 7, or whatever, triple line or double line, whatever. or a dummy customer account. Basically, we want to recognize that this is a part of a test transaction and not the real transaction. Okay, to differentiate, our goal is to differentiate them from the live transactions. Okay, then what else? Controlled testing. The system is designed to process test data as if it were real, but with safeguards in place. What are the safeguards? Output isolation prevents test results from mixing with the production report or the production data. Or the second thing which I discussed was the reversal mechanism, ability to quickly undo any unintended changes caused by the testing. Okay, so you're not only recognizing this by putting some mark, but you're also making sure that those transactions with those mark are not impacted in the live production dashboard, or with the production transactions. Okay, so either you can reverse the particular transaction, or you can have a mechanism wherein you are able to recognize that these are the test transaction, and it should not be having an you should not be mixing it with the production reports or the production data. Benefits of ITFs: realistic results. Testing in the production environment ensures that your results closely mirror potential real world outcomes. Okay. Next is software environment compatibility. It eliminates concerns about discrepancies between the test and the production version of the software. Okay, that is not that much relevant for this discussion. And what are the challenges and precautions? The risk remains. Even with the safeguards, ITF might involve potential disruption to the live processes, and there can be what? Performance impact. Testing should not slow down the production environment, or it should not negatively impact the users. Okay, so everything we have discussed with the help of the example also, so that you'll be a person, even if you have not gone through the domain number 3, still he will be able to understand, right? And if he is able to understand as of now, he'll also be able to understand much better in the domain 3 part. So with this, we finish the first technique, which is the ITF, integrated test facility. Yeah, so next thing is scarf. Now scarf is systems control audit review file. Big name: systems control audit review file. Now understand one thing. Okay, now this is very important thing for you to understand how this term got derived. So scarf is equal to SC plus ARF. Okay, SC is systems controlled and ARF is audit review file. Audit review file. So we'll be discussing how this term got derived, and what exactly do we mean by this scarf, systems control audit review file. So first we'll be understanding what do we mean by audit review file. First we will understand this thing, and then we will understand systems control. Okay, so what is audit review file? Okay, the name itself tells you, the word is what? Review. Okay, basically an audit review file is a set of data that you collect as a part of audit, either a financial audit or a systems audit, which you are going to review it at a later stage. Which you are going to review at a later stage. Very important. At a later stage, or which requires further clarifications. For example, let's say you find a transaction log where the user ID of the authorizer is absent. You find a transaction log where the user ID of the person who has initiated the transaction and the user ID of the person who has authorized the transaction are one and the same. You think that something is not all right, and then you keep this transaction aside for review at a later stage or at a later point in time. Or if let's say if it is financial audit, maybe you notice that certain payments beyond a certain transaction value or volume does not look all right, or maybe there can be logs which capture a time which is incorrect. For example, authorization time cannot ideally be before the initiation time, right? First you will be initiating and then you will be authorizing, but here you find that the authorization time is it is before the initiation time, so you find that something is not all right and you want to review this at a later point in time. So you build an audit review file. Now you say that let us highlight these transactions, keep it separately for a review at a later point in time. In other words, you build a review file which contains events, transaction, or something else that you think requires much more attention or deeper attention, which requires little bit more interpretation or clarification, and such files are called as audit review file. Okay, so the name itself is telling you its meaning, something which you need to review but not now, we'll be reviewing afterwards at a later point in time. Something you feel you find something is fishy or something is not all right and you want to look at it, okay, but you will look at it afterwards at a later point in stage. So that is audit review file. Okay, now how this term got derived, scarf, which is system controlled plus audit review file. Today, the thought process is when we have application software and automation, why can't we also automate the collection and review of such data through the system itself? For example, you build an audit module, and through that audit module, you set a parameter or a configuration saying any transaction beyond a particular threshold, please keep it separately for review. Any transaction which does not meet a particular criteria, maybe for example, like we said, initiated and authorized by the same person. So any transaction or any event, I'm just using the word transaction, but it can even be system based event. For example, you can say if somebody logs in at a time which the user is generally not expected to log in into the system. Again, now please generate an alert, keep it separately for review. Now, some data centers, they have this built-in kind of a mechanism where if somebody if somebody tries to open a door at an odd hour, then a log is generated, alert is generated, and these are not manually controlled. These are system controlled. So they have coined a term called as system controlled audit review file. It is audit review file, but it is not manually controlled. It is system control. They have a mechanism which triggers at a certain point of time, and they keep those kind of transaction or those kind of I'm sorry, those kind of system logs separately for the auditor to review at a later point in time. So that is system control, SC plus ARF, which is system controlled audit review file. So you build an audit review file for a real time alert, but you don't actually collect these kind of evidences manually. Okay, you configure them into the system, and then the system keeps pushing such transaction for a review at a later point in time. If you build such a capability, it is called as system controlled audit review file, scarf. All right, we'll be again looking at this, from this notes. So even if you have not understood, you will again, revise or review it, right? So what is scarf? System controlled plus audit review file. You should always break down these things, so that you will always be remembering what exactly this term means. Okay, breakdown of the acronym. System control, the process of collecting data for review, is automated and managed by the system itself and not manually by the auditors. And what is audit review file? A collection of data points or transaction event logs flagged for further scrutiny due to potential anomalies, errors, or security concerns. What's an audit review file? Audit review files are sets of data used by auditors to gain deeper insights or clarify potential issues within a system or financial records. Examples of flag data: missing authorization IDs in a transaction log, transactions initiated and authorized by the same user, it should not be there, so it will automatically be flagged. Payments exceeding predefined threshold, time discrepancies in logs, authorization before initiation. So there is a time discrepancy. Authorization happened before the initiation. We have discussed this. Unusual access attempts, logging in at odd hours from unusual location. Okay, from unusual location at different times. So again, that would be what? That would be flagged, right? How SCARF works? Automated collection. Auditors configure the system via an audit module to automatically identify and isolate specific types of data based on preset criteria. The system can be set to generate real-time alerts for immediate action when critical issues are detected. Example, unauthorized access attempts. Continuous monitoring. SCARF allows for ongoing monitoring of transaction and events, providing a more comprehensive and timely view of potential risk compared to the manual audits. And examples are transaction values exceeding a certain limit, specific user actions, example accessing sensitive data. Let's say if he is not allowed to access some data as per his role, and if he do that, again it would be flagged. Attempts to bypass security controls, any attempt to bypass security controls, system events occurring outside of the normal parameters. Benefits of SCARF: efficiency, reduces the manual effort because it is system control, required to collect and review data, proactive, enables early detection of potential issues and risk, comprehensive, provides a more complete audit trail by capturing data that might be missed in manual audits, and customizable, can be tailored to specific audit objectives and risk profile. So we have finished with the SCARF, which is system control audit review file. It is easy, it's not difficult. Okay, you can again go back, rewind, and revise this once again, because I always say whatever you learn, you'll be learning a lot of information. It is always good to keep revising, keep reviewing things, so that you do not forget things and you remember for a longer time. Okay, so by that we'll be looking at the next topic, which is the audit hooks. So next thing is audit hooks. So what exactly we'll be studying over here in audit hooks. So again, audit hooks are also again an automated set of mechanism by which you suspect some transaction or some event. Okay, basically you feel that some event or some transaction is suspicious. Now instead of stopping that transaction or stopping that event, you highlight that transaction, or you highlight that event, or you basically create a hook. The word here uses hook. Okay, so you hook that transaction or event. I'll give you one simple example. Because I'm sure many people might get confused between scarf and audit hook, because both might look similar. So first I'll give you an example, and then we'll discuss. Okay. So let's take an example of exam session which is going on in a classroom, where hundreds of students are sitting and giving the exam, and this invigilator or this particular teacher who is attending this exam session, that invigilator, I mean, he has not caught a student, but he feels that something suspicious is going on between two students, or maybe three students, or maybe one student. Like something unusual activity is going on. Now that invigilator is having two options. Either that invigilator can go to that particular student and give that particular student a warning, or maybe it can, I mean, the invigilator can ask the student to stop writing the paper, and maybe shout at that particular student or group of students. The second option is to get more evidence, to really understand what exactly, because the invigilator has is just having the feeling that something suspicious is going on, something unusual activity is going on, but the invigilator is not sure about what exactly is happening. So what will invigilator will do is that instead of going to that particular student and giving them the warning, uh, the invigilator will behave as if he has not seen anything. But now, from that particular time till next 15 minutes or till next 30 minutes, the invigilator will be having full attention to that particular group of students, like what exactly they are doing. So the invigilator will show, will pretend as if nothing has happened, but what exactly happening is that there is full attention of the invigilator on that, on those group of students, right? So this is what is audit hook. So what happens in case of audit hook is that, instead of stopping the transaction or stopping the event, you highlight the transaction or you hook the transaction or event. For example, in financial industry, especially with the fraud management and risk management, becoming very important. You see regulators like Reserve Bank and the stock market regulators like SEBI, when they feel that a particular account or a particular customer or a particular entity's transactions are suspicious, the earlier thought process was to block them immediately. But later they realized that suddenly blocking a transaction or suddenly stopping an event, they are actually alerting that particular person who is doing this fraudulent transaction or the fraudulent event, by which they are not able to really understand the modus of such transactions. So of late they have started collecting all these suspicious transactions and highlighting or creating hook in the financial system in such a way that wherever this transaction happens, wherever this transaction is repeated, whenever this user logs in once again, this transaction is highlighted because a hook has been marked against such person or maybe against such transaction or such events. Now when this happens, it is called as a audit hook. Okay, so instead of now again, I'm just stopping over here because we have also seen something known as scarf and then audit hook. Now some people might feel, okay, it is looking quite similar, but no. See, in case of scarf, we have created a separate review file, audit review file. So here important term was audit review file. We are creating a separate audit review file, which we will review it at a later point in stage. Okay, but in case of audit hook, what is happening is that whenever they feel some suspicious transaction or thing has happened, they will create a hook and they will start you know uh, paying attention to each and every transactions being done by that particular person or a group of person or maybe entity. Okay, so this is what is being achieved with the audit hook. So if you understand that example of that exam hall, you will really understand what do we mean by this term audit hook. So a audit hook is placed on such transaction or such events which require monitoring. So here our thing is, we are we want to monitor that particular person or the group of person or that particular entity because that entity has done something unusual. So we are creating a hook saying that now we'll be paying more attention to this entity. It also happens in case of income tax. Okay, if you do if you make some mistake or maybe if you evade your taxes, so what happens is that, and if the assessing officer, the income tax officer, if they get to know that this particular person does commit a lot of tax evasion, tax crime, so what they will do is they will create a hook in that particular entity saying that now going forward we'll be monitoring this particular entity because we feel that this particular entity there is something suspicious activities go on regularly. So for this particular assessee, so we'll be creating a hook and we'll be monitoring them continuously. Okay, so the purpose of the scarf and the purpose of audit hook is different. Okay, so a audit hook is placed on such transactions or events which requires monitoring but which cannot be stopped abruptly because they might alert the person or and they might never get to understand what is really happening in the back end. And this is very very popular in the financial monitoring space where they simply tag a transaction whenever and wherever this transaction flows in any part of the system. They're able to still track it. They try to create a mechanism by which they are doing regular and continuous monitoring of such events or transaction or such particular entity or such particular person, right? So this is what audit hook is all about, right? We'll again read from here. Okay, definition: an automated mechanism within a system that flags or hooks specific transactions or events for closer monitoring without immediately stopping or blocking them. Purpose: to track suspicious or unusual activities without alerting the individuals involved, allowing for deeper investigation into their modus operandi method of operation. See why I'm discussing in depth about these tools, these techniques, and why we are not directly jumping into the artificial intelligence, the third wave, is because, as I've told you initially only, that artificial intelligence, you'll able to really understand whether when you will be able to understand the second wave. And basically artificial intelligence is enhancing the capabilities of the second wave. So whatever we are able to achieve from the, with the tools which we are using in the second wave, we'll be having much more additional features, much more additional capabilities. The auditors would be able to utilize these tools much more efficiently. So basically you can say it is the next version of the cat tool. So if you are able to understand cat tools, then only you'll be able to understand the third waves, and you'll be able to appreciate, okay, now we are trying to go something beyond this thing. Okay. So it's like, in case of mobiles, so every year new and new technology comes. But if you're not able to understand what was the technology 2 years back or 3 years back, honestly you will not be able to understand what new features or new things, is brought in the market. So this is what it is, right? So how does audit hook work? Just a second. Yeah. How audit hooks work: identification. Auditors or system administrators identify potentially suspicious transactions or events based on predefined criteria or patterns. A special tag or marker called as the hook is applied to the identified transaction or events within the system. The system continuously monitors tagged transaction or events as they move through the system, right? Depending on the configuration, alerts can be triggered to notify relevant personnel, example fraud investigators, when a tagged transaction or event occurs. Use cases in financial industry: when suspicious patterns emerge in financial transaction, example unusually large transfers, transaction to high risk countries. Audit hooks can be used to track them without alerting potential fraudsters. So let's say, if there is maybe a war going on between two countries, or maybe there is no healthy relation between two countries, and we if a particular entity, they are having a lot of transactions with that particular country, again they can create what they can create a hook and try to, regularly monitor that particular entity and their activities, and the transaction and their events. Regulatory compliance: financial institutions can use audit hook to monitor transactions for compliance with anti-money laundering and know your customer regulations. Insider trading investigation: in case of suspected insider trading, audit hooks can be placed on the transaction of individuals under investigation to gather evidence without tipping them off. So with this, we even complete the audit hook, and in the next technique, we'll be discussing about the CIS, which is continuous and intermittent simulation. Hello. So the next technique which we'll be discussing is the CIS. Now, what is CIS? CIS is continuous and intermittent simulation. Okay. Now what is the meaning of continuous? This everyone knows. Okay, something which we are continuously checking, continuously going through it. Okay, maybe it could be a transaction we are continuously looking for, we are continuously checking the, I mean, when I say we are, it means the software, the auditing tool, it is continuously looking for, it is continuously checking. What do you mean by the term intermittent? Intermittent. Have you heard about intermittent fasting? What happens in intermittent fasting? We fast for 16 hours and then we eat for 8 hours. Then again we fast for 16 hours, we eat for 8 hours. We fast for 16 hours, we eat for 8 hours. So intermittent means in infrequent interval, like, it is not continuous. So Intermittent, it kind of mean it is not continuous, okay, at some intervals. So continuous as well as in some intervals, intermittent. What is the meaning of simulation? To create a test which exactly simulate the real environment. Okay, we have discussed about this, no, in the ITF, integrated test facility. We discussed, no, we have a test environment, we have a production of the live environment, and we want to check what we want to test each and every aspect of the production of the live environment. Okay, so when we are testing, it is nothing but we are creating a simulation of the live environment, simulation of the uh, production environment, right? Now this is the meaning of the term CIS. So basically under CIS, what we are doing, we are continuously checking, but at the same point of time, we are also taking some intervals. We are also taking some intervals, and we are what? We are taking some gaps, and we are testing some transactions. So continuously, as well as in some frequent gap, we are simulating some transactions. Okay, now this is the meaning. Now if you understand this, you will understand entire logic about this technique. Now very important to note that, whatever I have discussed till now, okay, this is something which I didn't spoke about. uh, uh, we have discussed about scarf, we have discussed about ITF, we have discussed about audit hooks, right? And now we are discussing about CIS. Now all these are what? These are not standalone software solutions. These are the techniques or approaches. The first thing, I mean, I don't know if I have spoken about this, but these are, whatever I'm discussing, these are what? CAT. What is the full form of CAT? Computer assisted audit techniques. So these are some techniques, these are some approaches. These are not some independent software solution with the name of scarf, with the name of audit hooks, with the name of CIS, with the name of ITF, anything. So it is not some independent software solution. It is a technique for doing what? For achieving continuous auditing. For achieving what? Continuous auditing. So our main goal, our main approach is what? Our main goal is to have what? To do continuous auditing. And to fulfill this goal, we have lot of techniques, we have lot of approaches. And whatever these five things, five techniques which we have, these are not some solution, these are some techniques or approaches, right? So even the CIS is what? It is an approach, right? Which is continuously checking for some transaction, but at the same point of time, it is taking some gap also for doing the simulation. So can I say, okay, now you will understand this afterwards, but I am just writing down the formula kind of thing. So CIS is continuous plus, okay, I'm not sure about the spelling of continuous because I always get confused, so don't mind about that. Continuous plus intermittent simulation, right? Now, if I again further expand this formula, it is nothing but continuous checking plus intermittent simulation. Continuous checking plus intermittent simulation. So it means that I would be continuously checking some transaction, but I will not be creating simulation of each and every transaction. I will not be testing each and every transaction. I will only be testing few transaction which meets my criteria. Okay, that's why they have used the word intermittent. Okay, intermittent means not continuous. I would be checking everything, but I would only be testing, or I would only be creating simulation in an intermittent intervals, in some if that particular transaction meets my criteria. Okay, but checking would be done continuously. But simulation will not be done continuously. Simulation will only be done in intervals if it meets our criteria, right? So I hope you understand at least this particular meaning of the term. Okay, now we will see example for this thing, right? Now let me take example of accounting software. Okay, now there would be few students who are not from accounting background, so they may or they may not understand this. But for you people, I'll be taking one more example. So in case of accounting software, and we want to check the processing logic of this application software, this accounting software. We want to check the application processing logic, whether it is giving us the correct output, correct results. Okay, now what will happen is that these employees, these accountants, when they pass the entries from the application software level, it goes to the dbms, and then ultimately it will go to the storage, which is the central database, right? And we'll be having cis somewhere over here. Okay, now what will happen over here is, just a minute. Yeah, now what will happen over here is, okay, now they are entering some transactions, and it is going through the dbms to the central database, and it is getting stored over here, right? And through the application software, right? And we have what, we have cis somewhere over here, right? Now, what CIS will do is that CIS will continuously check for each and every transaction. Okay, it is continuously checking what exactly the data is being, input by these accountants. Now, let's say if any of the transaction or any of the entry meets some criteria. For example, if a transaction is very material or is very important, let's say they are entering some transaction of value more than 10,000 USD. A transaction value is more than 10,000 US dollars. Okay, now we have set this criteria that for any transaction which is above this particular limit, consider this to be material transaction. So we will need to check what kind of entry, whether the application's processing logic, whether it is processing that particular data correctly, whether whatever whenever you put an accounting entry, it get reflected to the ledger accounts, it get reflected to the balance sheet, right? So whatever results we want to get, are we getting the correct results? Okay, this is what we want to check, whether the application's processing logic is behaving right or not. This is what we need to check. So and only for the material transaction. So the cis will continuously check for all the transaction, all the inputs, but it will not create simulation of every transaction. It will only create simulation of those transaction which meets the criteria. So here, let's say if any of the person has entered this transaction, now it will go to the cis, and now cis will look for what should be the standard entry, what should be the expected results from this particular transaction. Okay, and obviously we'll be having what actual results. Okay, so whenever that user is in inputting any data, it will go to the what ultimately to the database, and we would be having the actual result. And then we would be also what, we'll be creating a simulation or a test, what should be the expected result, right? Now this CIS will compare the expected result with the actual result. Okay, what is the actual result and what was supposed to be the expected result? If both are one and the same, there is no issue. But if there is some variance, if there is some difference, it will get recorded in exception log file. If there is some difference, it means that there are chances that the application is not behaving right. There is some processing logic error, and we need to find out what exactly is the error. So it will go to exception log file, right? I'll take one more example. Forget about the accounting software. I'll take one more example which might not be suitable based on this diagram. Okay, but still, we will take this example. Now let's say we take example of order management system. Just a second, I need some space for writing. All right. Let's take example of order management system. Now we are having some order, we are having this solution order management system, and the role of this is it automates the entire order life cycle, from order placement. Okay, it looks for the order placement, order processing, order fulfillment, order delivery, order returns. Right, basically it ensures efficient operation and basically positive customer experience. Right, so this we have a solution order management system, and this looks for all these things. Now we have set some criteria. Okay, now we are having a website, and we also accept order international orders. Okay, now we have placed some criteria saying that if I mean, we want to establish some materiality criteria, right? What is materiality? Important transaction. So in the above in the previous example, we have discussed about any transaction which is above the US dollar 10,000, that was material for us, right? So here also we are establishing some criteria saying that any order value which is beyond maybe like US dollar 5,000. Okay, it needs to be checked because of higher risk. We can also say that maybe any product category, for example, we are having like multiple products in our portal, and one of the category is electronics. Okay, and now we are putting that for this product category of electronics, we need to check more, because there is always a higher risk of higher return higher return rates, and also the complex pricing. Let's say, for example, we have put a criteria for shipping destination. Okay, because we are also accepting the international orders. So maybe order to certain international countries might be checked due to the higher shipping cost, or maybe due to the complex tax impact for that particular transaction. So if the impact is it is if the tax impact is complex, or if the shipping cost is higher, or maybe if we find that from a particular country we always get a lot of returns, specifically for those transaction which deals with these particular countries. Maybe, for example, we have some criteria based on the customer segment. Maybe we got to know that a new customer has ordered. He's not a regular customer, he has just sign up he just sign up on our website, and he has just placed a new order. So he's a new customer. So we always, if any customer is the first customer, we always try to deliver the best of the best service. Why? Because we want what smooth onboarding experience, so that that customer becomes our regular customer in the future. Okay, so also we want to check transactions which are relating to these customers. Okay, now let's say an order is placed of US dollar maybe like 6,000 for a laptop to be shipped to international address. This would meet the criteria and be selected by the CIS for checking. Okay, now let's say some other customer has placed order of $50 for a book, and that too it needs to be shipped domestic transaction. Okay, now this will not meet our criteria, and it will not be checked by the CIS. Okay, I hope you are able to understand what exactly CIS is doing. So wherever the transaction could be risky, the transaction could be material, so it is looking for the expected entry, or the expected results from that particular transaction. It is checking for that, whether the order management system, whether the applications processing logic is behaving right or not. So it wants to basically check that, and it will continuously check for all the transaction. It will continuously check for all the input, or all the transaction, but it will only simulate in intermittent intervals. In intermittent intervals. Okay, now I hope you understand now what is the how this term got derived. The formula of it, CIS, continuous checking plus intermittent simulation. So simulation or testing will not be do for all the transaction. Will only do in intervals, but checking would be done continuously. Okay, so this is the logic of CIS. All right, so this is the theory part of the CIS, continuous and intermittent simulation. Now, only this much is given in your review manual, you know, but this one becomes more difficult because, we need to understand what exactly do we mean by continuous, what do we exactly mean by the term intermittent, how this term got derived, all those things are not mentioned anywhere, right? And also, you need to understand one thing that, just to understand these three, four lines, so much background is needed, so whatever we have discussed, so if you don't know this background, these three four lines understanding will become very difficult. And that's what happened, especially with the CISA syllabus, that some places where they need more explanation, there they don't put a lot of explanations, but some places where explanations honestly are not needed, there they elaborate. Okay, anyways, so continuous and intermittent simulation. So during a process run of a transaction, the computer system simulates a transaction execution of the application. Okay, during a process run, you'll need to break during a process run of what? Of transaction. The computer system simulates, create test the instruction execution of the application of what it is checking. The application is processing logic. As each transaction is entered, the simulator decides whether the transaction meets certain predetermined criteria. A criteria which is already what? Already predetermined. If that matches the predetermined criteria, if so, it audits the transaction. Otherwise, if not, the simulator waits until it encounters the next transaction that meets the criteria. So basically it is checking for all the transaction, but it is only waiting for the transaction which actually meet that criteria, and then it will, do the simulation. It will create a test entry for that. This is the logic of continuous and intermittent simulation. All right, so with this, we also finish CIS, continuous and intermittent simulation, and the next topic would be snapshot, snapshot or extended record. This is the last technique, snapshot or extended record. Now, again, here also, just by looking at the word snapshot, you get to know that something screenshot, something kind of an image. They are talking about something kind of an image or screenshot. Yes, you're right. Or an extended record, we'll discuss about extended record afterwards, because extended record is nothing but multiple snapshots together. So we'll be discussing about that afterwards. So first we will be discussing what exactly do we mean by snapshot and what exactly is the purpose behind having a snapshot. See, understand one thing. In an application software, one challenge that we face as an auditor and even as an end user, who is an end user? The person who is ultimately, sitting in the operations team and working with the application software, the end user who is using that particular software, is we don't get to see what's happening within the application software at different stages of processing. For example, an error is generated which is displayed on the screen. We are not really able to understand at which stage of processing internally this error was generated. What caused this error? What is the internal parameter which caused this error? Was it something to do with the way we have configured the system? Was it something to do with the data input that we have given? That's not always clear by looking at what we can see on the screen. So you can place what is called as a snapshot at critical processing steps. So we are putting this snapshot at critical processing steps within the application in such a way that when that processing step is executed, the application will take a snapshot or an image or a screenshot of all the internal values. Okay, we don't call it a screenshot because screenshot basically means we are taking this I mean the image of the monitor, like what exactly is visible. But we normally call this as a snapshot because here we are taking what, the image or the snapshot of what, of the internal values at the stage of processing, and show it to you on the screen in a way that is easy to understand for us. If you do something like this is called as a snapshot. Now please note that you cannot play snapshot throughout the application because it will be self-defeating. If you can place a snapshot throughout the application software, it will generate so much of data that it will be self-defeating in terms of analysis, and analysis will not be possible. And by the way, this was an exam question in the past, that you need to place a snapshot only where critical processing steps are being executed. Because if you keep on taking the snapshot at each and every internal values, what will happen is that too much huge data would be generated, which will be self-defeating for the purpose of analysis. Now, when snapshots are placed at multiple sequential points, okay, now with the we are saying at critical processing steps. Okay, now when these snapshots are placed at multiple sequential points and then the snapshot values are correlated, it is called as an extended record or a trace, which is nothing but multiple snapshots which are correlated together to make a meaningful interpretation. So basically what will happen is that you can tell the developer or you can tell the programmer to place a snapshot at a critical stages of processing in such a way that when that line of codes or lines of code, what is line of codes, what are lines of codes or line of code, that we will again discuss in domain 3, which is the source code. When the developer, when they write the codes, when they do the coding. Again, I hope that this term is something which is very much, which will be very much familiar to everyone, which is the term coding. Okay, when I say, I mean, as an auditor, what we will say, we will tell to the programmer. Now when how we will say to the programmer, because programmer could be part of the management, right? See, understand, I have discussed about this in the past. We are talking about embedded audit modules. Okay, so that particular audit module, it is attached, it is fixed, it is inbuilt. It is what? It is inbuilt with the application software of the management, application software of the auditee, right? And we are giving them the instructions that we are developing this audit module. We want even this to happen. Okay, now you can tell the programmer to place a snapshot at critical stages of processing in such a way that when that line of code or lines of code are executed, it will generate a snapshot, a picture or an internal picture of the processing. Which picture? Internal picture of the processing, including the internal values, and show it to you in a way that is easy for us to understand as an end user or as an auditor. This will facilitate understanding of what processes are working properly, or what. So what is our ultimate goal? To understand what processes are working properly and what processes are not working properly, or what is causing an error in a particular phase of processing. Now that is called as a snapshot. I hope you have got what I'm trying to say over here. Okay. Now, for example, let's take an example in payroll. In case of payroll, gross salary computation is a critical step. So each application, so the application software has its own critical processing steps or logic. Now, at that critical processing step or logic being executed, you can embed a software which captures the before image and the after image. Like, throughout the image at critical processing steps. I mean, throughout the processing, not everywhere, but at the critical processing steps, you can capture what? The before image and the after image. Okay. Now, I'll give you one example. So it will look like this. So you're able to understand. So here, now, so this person is jumping. Now here we have taken a snapshot here, 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 here. But when you combine it together, it will give us the meaningful interpretation or meaningful result. and we are taking that image in a such a way that we can understand as an end user or as an auditor. So basically our ultimate goal is to, because understand one thing, we may or we may not be able to understand what exactly is that logic, but we need that software to capture that snapshot in such a way that it gives us a meaningful interpretation. We can have a meaningful interpretation on the basis of the multiple snapshots, and when these multiple snapshots are brought together, it is nothing but called as extended records. Okay, please note that these are all internal processing logic which is not otherwise visible to end users like you and me. So by looking at this image, you can identify whether things are working properly, accuracy is there, completeness, whether all the records are being processed, whether the processing logic is all right. For example, parameter values, string values, coded values inside an application may be of technical information which you and I cannot directly understand. So one of the functions of a snapshot is, while it captures the internal values, when a snapshot is triggered, it should represent in a way that is meaningful for you and me or the IS auditor. Internal parameter values of an application are technical pieces of information, right, which you and me may not be able to understand. So you cannot expect an external user to be able to interpret it. So one of the functions of a snapshot is, while it can pick internal values, when a snapshot is triggered, the same must be present in such a way that it is easy for an end user to understand what is being communicated, meaningful for the people who are reviewing it. The same way a snapshot at one place, snapshot at multiple, if you're able to establish snapshot at multiple places, if you're able to bring it together, correlate it, it is called nothing but extended records. That's it. It is as simple as that. Okay, I hope you have understood this entire thing, and if you're not able to understand, again you can rewind and rewatch this because this is not that difficult, and we will again review or revise it with the help of the theory part. Okay, so what are the snapshots? Purpose: to capture a detailed picture of the internal state of an application software at a specific moment during its processing. Implementation: software code is embedded within the application to trigger when the snapshot at critical processing steps. Output: the snapshot produces a clear, user friendly representation of internal values, of the parameters and other relevant data at that point in the process. Why are snapshots important? Error diagnosis: snapshots help pinpoint the exact stage of processing where error can occur, aiding in troubleshooting and resolution. Understanding of the complex processes: they provide insights into the inner workings of the application which are often not visible to the end users. Data validation: snapshots can be used to verify the accuracy and the completeness of the data during the processing. Critical consideration for snapshots: placement. Where are you placing? Exam question was asked. You should only place at critical processing steps. So snapshots should be placed strategically at crucial processing steps, not throughout the application. Data overload: excessive snapshot generation can overwhelming the users and hinder the analysis. Meaningful representation: the snapshot output should be presented in a way that is easy for auditors and end users to understand. This may involve translating technical internal values into the meaningful formats. What are extended records? What are traces? A sequence of multiple snapshots taken at consecutive points in a process. Purpose: to track the flow of the data and changes throughout a process, providing a mere comprehensive understanding of the system's behavior. Benefits of external records: detailed process analysis allows for a deeper understanding of how data is transformed and modified during the entire processing cycle. Identification of bottlenecks can reveal performance issues or areas where the process could be optimized. Okay, so we have already discussed this in the past. Okay, so basically we want to even check for the performance issues, or if there is or if there is error which is causing, so we need to understand what exactly is the cause behind that particular error. For that it will help you, right? Enhanced security helps to detect unauthorized changes or manipulation of data during the processing. So with this, we also finish what snapshots or extended records in information system. Basically, this is the fifth and the last technique for under the CAT tools, computer assisted audit techniques. Now, next thing which we will discuss is, some exam questions, which they can ask you from this topic of CAT, okay, which you must be knowing, which you must know, okay. So let's say if they ask you, mhm, let's say if they ask you, audit trail is required, audit trail is required, which out of the above five, or they'll give you four options, obviously. So, which one to go for? Which technique to go for? Audit trail is required. The answer would be snapshot. We have already discussed, we will be taking snapshot or that internal image of each and every critical processing step. So when a transaction is entered for processing, during the entire stage of the processing, at each and every critical steps which is being performed, we'll be taking what, we'll be capturing a snapshot or an image. So that will give you what, that will give you a meaningful interpretation, so it will help you as an audit trail. And that's what we discussed about the extended record or trace. So when they ask you a question, audit trail is required, go with the option snapshot. Next thing, they ask you, regular processing cannot be interrupted, regular processing cannot be interrupted, and we will send whatever we have identified in a separate file, and then maybe you can review it afterwards. Yes, you are able to remember it correctly. The answer is scarf systems control audit review file, when regular processing cannot be interrupted. Next thing, if they ask you which is not beneficial if we need to have a separate test environment. So separate test environment is required, but in which case, it will not be beneficial. When you need what, integrated test facility, when that is, as I've discussed that, we will be using ITF only in places where it is beneficial to test with production or with live environment. So the answer would be ITF. Next thing which they can ask you is, uh, transactions meeting certain criteria. Transactions, they've used the word transactions which is meeting what, certain criteria, needs to be examined, needs to be examined. The answer would be CIS, continuous and intermittent simulation. Okay, where we have discussed, it will be continuously checking, but it will only do the simulation when the certain criteria is met. Next thing is, this is again given in your review manual, when they use the word very very high complexity to use, which is that tool, which is the technique which is the very high, which is having very high complexity. The answer is scarf. This is something which you need to remember. Scarf, they also call sometimes as embedded audit modules, but embedded audit modules is a generic term. Okay, so but you need to remember these two things: very high complexity, scarf, or EAM, embedded audit modules. Very low complexity, answer is audit hooks. You just need to remember these two things. So very high complexity, scarf. Just a second. Yeah, very high complexity, scarf, or EAM, embedded audit modules, and very low complexity is audit hooks. So with this we finish even the topic of CAT, which is the computer assisted audit techniques, and now we'll be going with the artificial intelligence and machine learning in IS audit topic. Alright guys, so the time has finally come when we'll be starting with the discussion on the third wave, which is the artificial intelligence and machine learning in IS audit. Okay, now it's very much important that you do watch the earlier part as well. Do not directly jump from this amendment part. Otherwise, you will not be really be able to understand things and not be able to, relate with the previous topics, right? So let's start discussing. All right, 1.8.4, artificial intelligence and machine learning in IS audits. The initial lines in your review manual says that IS auditor can leverage artificial intelligence and machine learning. Now we'll be discussing, the difference between artificial intelligence and machine learning. Okay, what is machine learning? What is deep learning? What is, robotic process automation? All those things we'll discuss, but not right now. We'll discuss one by one. We'll go slowly. Okay, and in case if you want to review or revise something, you can take a pause again, rewind the video, and again you can rewatch whenever you get stuck. Okay, everything we'll discuss, but one by one. Okay. uh, IS auditors can leverage AI and machine learning techniques to enhance audit efficiency and reduce audit risk. Okay, what is audit risk? Audit risk is equal to inherent risk into control risk into detection risk. Now, how this formula got derived, all those things I won't be discussing as of now, because this is something it will take a long time to discuss, and we have already discussed in the past. So I'm not going to waste time over here in this discussion on the derivation of this formula. But in simple terms, if we want to say what is audit risk, material and significant control weakness, or you can say the vulnerabilities within the IT systems and the processes will go undetected by the auditor. The auditor will not be able to detect what? The chances that the auditors will not be able to detect the material and significant control weakness or the vulnerabilities within the IT systems or the processes. This is nothing but the audit risk, right? And with the use of this AI and machine learning, it will reduce the audit risk and it will enhance the audit efficiency. Okay, by automating manual tasks like audit work papers and data manipulation, automating the manual task. Okay, AI ML can streamline audit processes and save time. Okay, now this thing, it can save time. Again, we have discussed in the past, like, I've told you that if you look at audits today, both financial audits and system audits, most of the time of the auditor is spent on data collection part, while actually the auditor should be spending more time on analyzing this data and interpreting whether the controls are in place or controls are not in place. They spend actually more time in the data collection part because they want to collect complete data, they want to collect correct data, they want to collect the data from different sources, right? Now, forget about only just data collection part. With the help of the artificial intelligence, with the help of this machine learning, even the data analysis will be done for us. Now it is on the auditor to establish which data analysis, like, we'll be having a lot of data in front of us, so which where to focus and where not to focus. That will be the basically the goal of the auditor as of now, because most of the things would be done by these tools. So the focus area will change. I've already told in the past, it will not happen that these artificial intelligence, we will be also discussing a lot of risk, with regards to this artificial intelligence, because always understand one thing: returns always comes with a risk. Returns always comes with a risk. So when you are having returns, you also have what? You also have risk. So we'll be also discussing about various risks. But understand one thing: lot of automation will be happening. Lot of uh, it will try to make the entire audit process easy. Okay, lot of data collection, data analysis would be done. But where to focus and where not to focus, that will again be a task for the auditors, right? So additionally, these technologies can help decrease audit risk. decrease audit risk by enabling larger sample sizes and providing auditors with more time and information to thoroughly analyze audit results. Again, the same thing it is saying, that you will be getting more time to do what? To thoroughly analyze audit results. Okay, leading to improved testing and follow-up procedures. Again, so whatever we have discussed, the same thing is getting repeated over here, because now your focus area will change, right? So your testing would be improved, audit risk would be reduced, and follow up, even the follow up procedures would be improved, right? Now, traditionally, computer assisted audit techniques we have already discussed, often referred as wave 2 tools. Okay, they are rule based. We have already discussed about this. They are rule based because we used to put the rules, we used to, whatever we have discussed, the scarf and even the CIS, we have discussed, it has to meet a criteria, predetermined criteria. So we have already put some criteria, right? And so it was rule based, right? And I have also discussed that there would be a lot of role of the auditors, because they need to configure, just like the way you configure some any application software. Okay, similarly this audit model also you will need to configure, right? They can only perform tasks that have been explicitly programmed or configured by a human user. For example, a CAD tool might be programmed to flag all transaction over $10,000, but it won't discover unusual patterns or anomalies outside of those preset rules. So whatever things we have told to that particular tool, that it will do, but it will not think beyond that. But this is what the third wave comes in, the artificial intelligence and machine learning. This is where the role of artificial intelligence comes into the picture. It thinks beyond the cat tools. So where the thinking of the cat tool ends, right from there, the thinking of these, AI tools will start. Okay, we'll go one by one slowly. Don't get scared, by this topic. This is very easy topic, right? And honestly, from exam angle, like if you even if you review the, like if you go to the official review manual, they have given very small data on this amendment, so it's not a big in terms of the contents or the pages for the artificial intelligence and machine learning. Very less data is given, right? In fact, we'll be discussing a lot more than what is there in your review manual. Okay, so from exam angle things would be very much easy, right? And as I've told you that we are still on the end of the second wave, and we'll still need to figure out how things can go, and still there are a lot of scope for improvement of the this AI and machine learning, right? All right, so what we have learned till now is what I've told you till now: cat tools, artificial intelligence, machine learning. The approach is rule based over here, right? So there was no self learning, there was no self learning, right? It used to rely on the human input to define the rules and the criteria. But in case of the AI and ML, what is going to happen is this has the capability to learn from data, and improve the performance over time without explicit programming. Okay, how it will get data? Again, there are various sources from where the data will need to be put for the algorithms. We'll be discussing about that. But whatever historical data of our organization, or either the internal data or the external data, whatever data we get, we feed into these algorithms. It has the capability to self learn. It can learn a lot of things, risk from various areas. Okay, whatever things we might get for we might miss over here, that will be captured with this tool AIML, right? So it is very much efficient as compared to the cat tools. That's why I told you it's very important to understand what was the level of things or the level of task which CAT tools can perform. If you understand that, now you will understand what level of things you can expect from the AI/ML. So here it will learn from the data, it will identify patterns, anomalies or the abnormalities, and potential risk, not explicitly defined in rules. Very important to know this. Okay. All right. So let's proceed ahead. AI and ML. Artificial intelligence and machine learning offer a significant leap forward in this regard. These technologies can learn and adapt. Unlike traditional CAT tools, AI and ML models can learn from the data patterns and adapt their behavior over time. This means they can identify anomalies and risks that weren't explicitly programmed into the system. Okay. Discover hidden relationships. AI ML can uncover complex relationships and correlations within the data that might be invisible to the human eye or the traditional rule based systems. This can lead to discovery of fraud, errors, or inefficiencies that would otherwise go unnoticed. So as I've told you, the thinking, the way that the analysis would be done would be much more efficient than the second way, than the CAT tools, right? Reduce manual configuration. While AI/ML models still require some initial training and guidance, they can significantly reduce the need for manual configuration compared to a traditional CAT. This allows auditors to focus on higher level analysis and decision making. Always understand one thing, whenever someone tells you, okay, AI is going to replace auditors, AI is going to do this, it will never happen. If it is solving some problem, other problem will appear, and the auditor will be focusing on much more higher level analysis, or things which are of higher value. Okay, if your time is saved in some activity, you can utilize that time in some other activity. It's like this, I'll give you one simple example. Okay. Let's say, you are studying for CISA. Okay, you have watched my lectures, you have, gone through the official QA, you have gone through review manual, you have finished all of our mock test, everything, the LDR notes and the MCQ blockbuster series, everything you have finished. Whatever I have we have in our portal, everything we have finished, and also things which are, beyond our portal, even that also you have finished. You have done the revision, everything you have done. Okay, now you have extra time. Now, will you waste those extra time, or will you utilize this extra time somewhere else? Maybe you might think of, going and reading the ISACA journals. Very important. In fact, you know what? These amendments, how I got to know that some of the amendments, like even 6 months back, I knew some topics which will come in the amendments because of the ISACA journals. Like every 1 or 2 months, they release the ISACA journals, and in the journals, they have a lot of topics, and normally the amendments come from those topics only, right? So right now you have extra time. What else you will be doing? You have already finished everything, you will be utilizing your time somewhere else. So no matter how much you are able to save your time, you will have something more valuable to focus on. Okay, so it will never happen that it is 100% replacement. No, right? So all right, so let's proceed ahead. Okay, so you need to understand that it is important for the practitioners, these IS auditors, to understand what algorithms are. Okay, now we'll be discussing about the audit algorithms and why they matter, why these audit algorithms matter. We also need to understand that humans have main role in algorithm design and metrics. So it is the auditor's job to ask questions, and it is important to remember that errors are possible even with the most advanced algorithms. Errors and mixed mistakes are possible even with the most advanced algorithms. All right. So what does the theory says? Machine learning is a subset of artificial intelligence. If this is AI, machine learning is a subset of artificial intelligence. In fact, what is machine learning? The name itself tells you it has the learning capability, the self learning capabilities. Okay, is a subset of artificial intelligence that focuses on enabling computers to learn and improve from the experience without being explicitly programmed. In simpler terms, it's about giving computers the ability to learn patterns from data and make predictions or decisions based on that learning. When discussing AI tools for audit, it's accurate to say that they have self learning capabilities, but it's important to understand that these capabilities are driven by the underlying machine learning algorithms. Very important. Okay, even though we are saying they are having self learning capabilities, it's important to understand that even these self learning capabilities, from where they are driven by the underlying machine learning algorithms. Okay, they have also given theory on the audit algorithm part. So whatever I'm discussing, you can say I'm discussing more than what is given in the review manual, but everything I'll be discussing over here, okay, with respect to all the amendments part. Okay, these algorithms are the brains behind the AI tool, and they indeed need to be continuously fed with large amounts of data to learn and improve. And what are the data sources from where these machine learning algorithms they will be getting the data? Internal data. This includes your organization's financial data, operational data, transaction logs, etc. The AI tool learns the specific patterns and nuances of your organization's operations by analyzing this data. External data. So not only your internal data, but also from the external sources. This can include industry benchmarks, regulatory updates, financial market data, and even news article with regards to the fraud or the risk by analyzing the external data. Okay, it will include everything. Regulations, frameworks, standards, almost everything. So not only the internal data, but also the external data. And when you are feeding all this data, it will be able to self learn things, and it will be able to enhance the capabilities of the existing tools, the audit tools. The second way which we have discussed about the cat tools, right? So cat tools were rules driven, so we need to give all the rules, and then it needs to do the it needs to perform. But here we can give rules, it's not that we cannot give rules, but it will have its own audit, machine learning algorithm or the audit algorithms, and from where, and these algorithms will be continuously be required to fed data either from the internal sources or from the external sources, right? The AI tool can stay updated on the latest trends and risk in your industry, allowing it to make more informed decisions. Okay, continuous learning. Okay, now before this I'll be discussing something else also over here. So understand one thing, very rare kind of decisions. So if the data goes into these systems, if it is not regulated, okay, it can come up with a totally different output by which the impact can be much higher. That's why they say look at how data governance is managed, look at how decision logic, look at the level of expertise that was used. Not everybody is an expert, so you need to understand from where the data is being fed into these systems. Not every source is relevant for you. Not every source is an expert. Not everybody's input needs to be taken care. Okay, there has to be validation on what kind of inputs can go into these expert systems review. The security to these knowledge bases, because understand one thing, they can become a concentration of lot of sensitive information in a single place, so the way we discussed about the CIA, confidentiality, integrity, and availability. Again, I'm telling you, we'll be discussing in depth in domain number 5, right? So whatever security aspects we have for the other system, we need to even have for the our algorithms also, right? Our systems, these AI systems as well, because they can become a concentration of a lot of sensitive information in a single place. That's why we say we'll need to be very, very robust in terms of information security. In fact, some of the private enterprises, they have not even opened up these systems to others. Okay, most of the organization, they have their proprietary, versions, because understand one thing, for the simple reason that you're also feeding the internal data, and you cannot share this internal data with other organization, right? Or you cannot share it in public domain. So the algorithms are being fed with internal data as well as the external data. Now internal data are what? Confidential, highly sensitive. If these data gets leaked out, it can create a huge impact to the organization. And also we need to be very much cautious about from where these the data sources from where these are being fed into these systems. Very, very important, because we cannot just blindly rely, okay, AI is doing something, oh wow, wow, it's really good, okay, I'll be doing this. No, no, we cannot do that. We need to understand, what is the background, or you can say the back end from where the data is coming over here, the data sources, whether those are reliable or not. So all these things we need to decide, and definitely it is a very challenging task. So IS auditor alone cannot do this. It needs to be done in a group. We would be needing a lot of experts to help us understand, because IS auditors may or may not have that kind of expertise. See, we are discussing something which will happen in the future. It has already started, and it will grow to a great extent. But honestly, we are not ready for this. Individually, on an individual basis, we may not be able to even understand how things are working. So it could be challenging task for the auditors. And right now, in the market, like if you look at this Deloitte and all these big four, they have also started giving the algorithm assurance services. What? Algorithm assurance services, where they give you assurance on the high quality data and unbiased data. Okay, now there is something known as bias in AI, again, that we'll be discussing very soon. Okay, but what I'm trying to say over here is that so there is also something known as algorithm assurance services, which are now being given by the big fours. So basically we were discussing about these algorithms. These are all what? These are proprietary, these thing solutions, and it is not shared, because it is very, very, it is having very, very sensitive information, and it can actually make, or it can break an organization. They have so much of information within them that if it falls in the wrong hands, it can be severely misused, and it will they will lose, the organization will lose their competitive advantage, right? All right, so let's continue with this continuous learning. Okay, the AI tool doesn't just learn once and then stop. It needs to be continuously fed with the new data to stay relevant and adapt to changing environments. This is why many AI audit tools are designed to integrate with your existing systems and automatically pull in new data as it becomes available. Okay, very important again. Algorithm refinement. As the AI tool learns from more data, its algorithms are constantly being refined and improved. Okay, so it is continuous improvement is there. This means that the tool's ability to detect anomalies, predict risk, and make accurate decisions will get better and better and better and better over time. Right? Again, very important, human in the loop. While AI tools can automate many audit tasks, it's crucial to remember that human expertise is still essential. Auditors play a key role in interpreting the results generated by the AI tool, making informed decisions and exercising professional judgments. So guys, this was the thing I was talking about is algorithm assurance services, right? So if you see, have trust and confidence in your technology investment. This is the page of Deloitte, and they have also started this service, right? Algorithm are used to drive efficiency, deeper customer relationship, and enable the agile decision making. So our services empower you to clearly to see clearly whether your algorithms are performing as they should. And also they are talking about managing algorithmic risk, right? So this is a kind of a new service. Again, we don't have this thing in our syllabus, but then they have, discussed about the audit algorithms, right? Also, there is one more thing I wanted to show you before we move to the, AI bias topic, right? See, understand one thing, why it is important that these algorithms should be fed with the right data. Okay, see, I'll not take example of this audit thing, but let's take example of something different. Let's say we if we discuss about expert systems, which is built for the doctors or for the medical profession, which if it gives wrong output, it can actually mean, just a minute. Yeah. So if an expert system is built for doctors of the medical profession, and let's say if it gives wrong output, it can actually mean you could lose a lot of lives, because you could go wrong with the wrong diagnosis. Okay, we hear this thing a lot, like the doctor has done the wrong diagnosis, or the diagnosis was not done in the right time. Now, when it comes to the doctors and individual doctors, we still see, okay, we can have some I mean the in the end, doctors are humans, they can make error, they can make mistakes sometimes. They can take legal actions also against those kind of medical professionals if they were really careless or ignorant. But we cannot expect the same thing with the systems. The systems, if it start giving the wrong diagnosis, or the wrong output, things can go really crazy. So hence these systems are very 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 closely guarded in terms of what kind of data goes into these systems, what kind of decision logics are built into these systems, who is considered as an expert to be good enough to contribute to these systems, because they don't want somebody to deliberately give a wrong data into these systems, right? This is called as poisoning of the data. Again, this term poisoning of the data, it is not there in our syllabus, right? But what it means, that cyber attack in which adversary intentional compromises a training dataset used by an AI or machine learning model to influence or manipulate the operation of that model. This is data poisoning, right? So that's why we are talking a lot about this particular aspect, right? And also before we look at the AI bias topic from the NIST, which is again it is additional topic which is given by me, because in your CISA review manual they have just discussed one or two lines about the bias, and that too they have only discussed about the human bias. But then bias is also having three categories as per the NIST special publication 1270, where they say systemic bias, human bias, statistical bias, right? We'll not be going in depth because that is not a part of his syllabus, but then we'll just look at the overview, or the just a small highlight from that NIST standard. Okay. Before that, so I just wanted to show you some, this news of, I'm sure everyone must be knowing about this thing. So this was updated on February 28th, 2024. So it's a recent news, right? So even the Google CEO, he admitted the fact that yes, there was some bias in their Gemini. Previously it was called as Google Board, then they changed the name to Gemini, right? So, and it was with link with the racial bias. Okay, you can, if you don't I mean, I'm sure everyone must be knowing about this thing. If you don't know, you can read about this news. Okay, but what he told was, I know that some of its responses have offended our users and shown bias. To be clear, that's completely unacceptable and we got it wrong. Okay, our teams have been working around the clock to address these issues. We are already seeing a substantial improvement on a wide range of prompts. Okay, one more thing, good thing he told, no AI is perfect. What? No AI is perfect, especially at this emerging stage of the industry's development. But we know the bar is high for us, and we will keep it at it for however long it takes. And we will review what happened and make sure we fix it at scale. Before I go much about this topic of AI bias, I just want to give you my I mean, I could be wrong, here. This is what I have experienced myself. Again, I mean, I'm not saying that this is right or this is wrong, and I could be wrong over here. But like I have used both, and the Google Bard as well as the Chat GPT. Okay, so I'm talking about my experience, which I faced, almost like 1 year back. So when I used to, ask some questions to the Chat GPT, it used to give like thug life moments, thug life moments. If something is right according to Chat GPT, it used to say, no, this is right. If something it feels it is wrong, it used to say directly on the face, no, 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 you are wrong, absolutely wrong. But this Google bar, it is, it is like a golden retriever, very cute, very sweet. Whatever thing I used to say, it used to say, yeah, you're right. Even if I used to, input some wrong data, okay, if I used to say, okay, I feel this could be right, and then it used to say, yeah, you make sense, you are right. But even this can also be right. I mean, like he used to never talk like, this is wrong or this is right. It used to always give diplomatic answers. Which one? Google Bot. Okay, things might have changed now. Okay, but this is what I have experienced, in the past, that one tool was giving a thug life moment. If something is right, go to hell. I know I am more intelligent than you. This is right and this is wrong. Okay, but the same question, the same data, if I used to put into the Google Bot, it used to give me diplomatic answers. In fact, it changes your answer on the basis of the input which you give. If you give, I'm getting confused, I feel this can be right, those kind of input, it should never make you feel bad. It used to always say, yeah, you also make sense, but you can also think in this angle, but yeah, you are right, you are absolutely right too. And when we used to say, no, no, I think this is wrong, this is totally unacceptable, this is wrong, and then it is to give the output, yeah, you are correct, this is wrong. So the output used to be, I mean, they used to manipulate the output on the basis of what input you are giving. But at the same point of time, as I've told you, for the Chat GPT, I have faced this thing almost like 1 year back. I don't know what things happens now, because I don't think so I have seen that kind of scenario as of now. But then this is what I faced once upon a time, that Chat GPT was like, no, 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 this is right, this is wrong, you go to hell. If you want to take my help, you need to respect me. I mean, obviously these kind of words are not used by that tool, but then again, I mean, I'm just giving you some exaggerated example, but this is what used to happen till 1 year back. So this is also kind of what manipulation in the output, right? And as I've told you, all returns, it comes with a risk. Similarly, here also, when there is a return, so every return will come with a risk. So here also there is something known as bias in the context of AI. So as I've told you, AI is not taking decision based on themselves. AI is not taking decisions based on themselves. It is a kind of mimicking how humans take decisions, right? It's taking decision based on what data is fed to them, and so that's where the bias comes in. All right. So again, we will not go in depth because this is not a part of a syllabus. In fact, any standard or any framework, this is never a part of your syllabus. Will never be a part of your syllabus. This is something which you need to remember. So NIST Special Publication 1270. It is with regards to towards a standard. Standard for what? For identifying, okay, and managing, okay, bias in artificial intelligence. Okay, so it is, I think, approximately 100 pages document, 80 pages, I guess. You can see the index over here. Again, we'll not be going in depth here, right? So this is the index, right? AI challenges and guidance, uh, categories of AI bias, very important. Categories of AI bias. Then what else is given? Human factors challenge, guidance, right? So for us, we'll be looking at the categories of AI. So as I told you, there are three categories of AI. Sorry, bias in AI. Three categories of bias, right? Systemic bias, human bias, and statistical or computational bias. Now, what exactly is systemic bias? What exactly is human bias? We'll just take one or two example. Okay, now they have also theory for this part, systemic bias. Okay, so systemic bias is you can say a kind of a historical bias. So this type of bias arises from outdated or unadjusted systems or algorithms that consistently produce the old results due to the reliance on historical data or rules that no longer reflect the current realities or conditions. Okay, so that's why we say it is very important to keep updating the data which is being fed to these algorithms. It needs to be current. Secondly, it needs to be we need to take care of all the possibilities, all the permutations and combinations. So let's say you are feeding some data in these algorithms, and if you are feeding these data with the help of some we are taking some samples. Let's say if we are having thousands of data and we have taken some samples to feed these data into the system. These samples should reflect the entire population, right? And here also it should not be a very old data or outdated data. Okay, so systemic bias is kind of, you can say, historical bias, right? So for example, an IT audit tool is configured to flag transaction over a certain amount for further review based on historical fraud patterns from the company data. However, if the tool does not account for legitimate annual increase in the transaction sizes due to inflation or the business growth, it might systematically flag increased transactions as suspicious. Okay, now let's say we say a transaction beyond this particular limit you need to review, it could be suspicious. But that data is taken, it is very old, it is 5 years old data or 6 years old data, and now the inflation has increased so huge. Okay, now it is very much normal that that particular limit is it is not that high limit. So if the data is not correctly updated, okay, so it can make what? It can make systemic bias in the results, in their output. Or let's say there is one organization, and on the basis of its past records, we the AI, the algorithm gets to understand that this organization is not hiring a lot of women employees. Okay, most of the male employees are being hired by this organization. Okay, now let's say it is kind of filtering, so a lot of applications that organization have got for some particular role, right? So if that AI is filtering a lot of CVs and applications on the basis of the historical data, saying that this organization is hires a lot of male employees only, so I will be biased towards the male employees. I mean, I'll not be selecting the female uh, candidates, but I'll be preferring more of the male candidates. If this kind of decision is being taken, again, it's what? It's systemic bias, right? And then the next thing is the human bias. Okay, next thing is the human bias. Okay, so basically this occurs due to the subjective judgments, perceived notions, or personal experiences of individuals. Again, human bias also we have discussed somewhere in the non-statistical sampling or the judgment sampling, that we have told, no, the auditor is using his own judgments, and he could be biased, right? Because now he is using his own expertise, his own knowledge, his experience, professional skepticism, right? So he can be biased on his decisions when he's looking for a sample on the basis of his, on the non-statistical sampling methods, or you can call judgment sampling, right? So we have discussed this in the past as well. So basically, human bias, as a name itself tells you, this is occurring due to the subjective judgments, preconceived notions, or the personal experiences of the individuals. For example, if auditor feels, okay, transaction with some particular country, it means that, I mean, if he feels some particular country's transaction could be suspicious, because that country, I mean, if they have some kind of preconceived notion that, that country deals with a lot of fraudulent activities, it's not good. If that kind of preconceived notion is there, it is again example of human bias. I won't be taking an example over here because I don't want to get into all those kind of stuff, but if this kind of notion you are having, it is what it is, human bias. And if you make the systems like this to think that, this country transaction, always flag it, it is what it is, example of human bias, right? Next thing is the statistical bias, statistical and computational bias. Now, statistical bias, again, we have discussed this in the past. It occurs when the data used to train an AI system does not accurately represent the population for which the system is intended. Data set that is going to be fed into these systems. Now we have to select the sample of the data, right? Now, which is going to be part of the input to this AI system. Now we need to make sure that that those samples represent the entire population. Okay, so this is something which we have discussed in the statistical sampling also, that if you are taking the help of these statistical tools, it should what it should represent the entire population. Now let's take one example. When setting up a new system for monitoring network traffic. Okay, we are having new system for monitoring network traffic. By the way, I would like to add something. If you're not able to understand something, maybe because because we are also discussing some aspects from domain 3, some aspects from domain 5. If you are not able to understand anywhere in between, it's completely fine. It's completely understandable. So don't get panicked that something you're not able to understand, or something you're not able to digest the fact, because I know we are talking or discussing about domain 1, but the topic is so vast, AI, machine learning, we have to bring the other domains as well over here, right? So don't worry about that part. Okay, so the example is, when setting up a new system for monitoring network traffic, the sample data used to configure the system's sensitivity to anomalies is taken from a period when a large scale cyber attack occurred. So now the data, the sample data, let's for example, if the sample data is taken from a period, okay, okay, which is the period when there were a cyber attack which occurred. So basically, it is not, the data is not taking all the possibilities, because you cannot say always cyber attack will happen, right? Or with that organization, let's say the internal data which is used, okay, and the internal data represents the period where when the cyber attack happened with that particular organization. Or maybe if you're taking the external data from a period, only from that particular period when this kind of thing happened, so the sample is not representing the entire population. It is not taking into consideration all the permutations and combinations. So this would make the systems to be overly sensitive to similar patterns, classifying even the regular activities as abnormalities or anomalies. Since the data was fed into the system and that data represent that period when the cyber attack happened, so the algorithm is classifying even the regular activities, Even the normal activity is also something as suspicious. So it is giving a lot of false alarm, lot of false positives. Again, false positive term we will be discussing in domain number 5. Okay, so it is giving you a lot of false alarm. This statistical bias result because the training data does not represent the normal operational conditions. It is not taking into account the normal operations conditions, leading to high false positive or false alarm in the anomaly detection. Right? So this is nothing but statistical and computational bias. Now with this, we also end this topic of AI bias because there is not nothing much to discuss over here. It's a small topic, but you need to understand this. Like it's very important for you to know that this is a risk. AI bias is a huge risk because when like we cannot just discuss about returns from the AI. We also need to look at the risk. In fact, as an auditor, your focus should be always on risk. If something good is coming, you should not be only focusing on the good things. You should always be focusing on the bad things. What can be the risk over here? Like your mind or your thinking or your analysis should always go into the risk factor. Don't you think so? Right. So here also AI AI can do a lot of wonders, but our role as an auditor is to always and always and always try to look for more and more risk. Correct? So with this, I take a pause over here. If you want, you can just rewind things and whatever things we have discussed in this AI, you can just have a quick revision before we proceed ahead. All right, thank you. All right, everyone. So we have just finished the discussion on categories of AI bias, where we discussed the systemic bias, statistical bias, and human bias, right? Now, the next topic is your AI tools in the entire audit life cycle. When I say audit life cycle, again, this is something we have discussed overview in the past that, these AI tools will be helpful, from audit setup to audit planning to audit field work to audit reporting to audit follow-up. How these AI tools will help you? So we will, note down few things. So now you will have to write down few things, right? So I'm giving you some space, to note down few points, and I know that you have been listening to the video since past 3 hours now. I think it's already 3 hours, which I can see. So right now I think you'll need to open a book or something, and you can just take down few notes, along with me, right? So the first thing is audit setup and audit planning. You can say both together. Okay, we generally not say audit setup as a separate thing, right? We can mix both the audit setup and audit planning, right? So let's take down the notes. Audit setup, right? First thing, it will help you for what? Risk assessment. It will help you for risk assessment. Now AI will analyze historical audit data. It will go through the past previous data, previous reports, previous audit data, and it will identify and it will help and identify what? High risk area. High risk areas. Now this is something we have discussed in the past also, that auditor needs to focus on what? High risk areas, because understand one thing, the resource is limited. You cannot do audit now. When I'm saying we have audit tools, that is something different. Okay, audit tools, definitely audit tools will establish what? Continuous auditing. But what I'm trying to say over here is that we always need to focus on high risky areas, because there are critical areas, there are high risky areas, but then there are also medium severity areas or low severity areas, so their auditor need not focus. So you have first see understand, if I have hundreds of issues in my controls or in my organization, in the form of a lot of vulnerabilities or whatever things. So initial my as an organization, initial I'll be try to solve the critical areas and the high risky areas. I'll not be that much concerned about the low risky areas. Okay, similarly, even when you are like you are going to appear for the CISA exam, right? So you have lot of things to revise. So first you will revise what? First you will focus on what? You will focus on important areas, right? And then when you have extra time, I'm talking about the revision part. Okay, now in case of learning, you need to learn 100% of the things, right? I'm just giving you an example over here. Okay, but in case of the revision purpose, you will be focusing first on the important areas, and then on the less important areas, right? Similarly here also same thing happens. Now here AI will do all this work, and it will analyze the historical audit data, and it will identify the high risk areas, and it will kind of guide you that you can focus on these areas during this particular audit, right? Next is resource. Let me change the ink color. Resource allocation. AI will optimize. Why we use the word optimize? Because we always say optimum utilization of resources. The best utilization of resources. If you are having 3 months in your hand for studying for the CISA exam, you will do what? You will optimally you will try to utilize these 3 months, right? You will take the best utilization of these 3 months. Okay, in case of some people, they have these kind of deadlines. So whenever we talk about resources, whether in the form of money or in the form of time or in the form of human resource, we always strive for what? Optimize utilization of resources. So AI will optimize what? AI will optimize the allocation of auditors. What? Allocation of auditors based on expertise. Sorry for my bad handwriting. uh, Auditors based on expertise and risk levels. Okay, now understand one thing. Again, this is something we have discussed in the past, that audit will happen in a group, right? So it's not that only one individual person will go and do the audit, right? There will be a team of people, right? So which person to be assigned to what task? There would be junior auditors, there would be senior auditors, there would be one person who would be leading the audit team, there would be audit manager, right? So we need to, and there would also be experts, right? We can also take help of the experts, we can also take help of the pen testers or cybersecurity experts, or maybe lawyers, in case we are not able to understand the regulations or laws, something, and the impact of that on the client. So we can also take their experts help, right? So whenever we are doing all this kind of thing, right? So the AI will also optimize. It will give you guidance on how you can allocate the auditors based on their expertise and based on the risk level. So for example, AI will assign this example, right? AI will assign what? A cyber security expert, a cyber security expert to the high risk department, right? So this is how the AI would help over here in the resource allocation. What else? What next? Now we will talk about the audit planning. How AI will help you in your audit planning, right? It will help you for scope for defining the scope. So AI will suggest you areas. Again, AI will suggest you audit areas. AI will suggest audit areas based on based on risk assessment and industry benchmark. Example example, ai recommends focusing on data privacy controls. Now you might be knowing that the data privacy regulations, it got levied in a lot of countries across the globe, right? Lot of lot of economies, a lot of countries are going for these laws on data privacy, right? So let's say if it's a new law in a country. Now the AI will know everything, that you are the location is this thing, and you are kind of auditing this particular department or this particular area, and these particular laws are applicable for these particular data. The client is based on this particular industry, maybe banking, financial industry, or whatever, right? So AI can analyze everything, and it will tell you what focus on data privacy controls due to it will also give you reason, due to regulatory changes. So if there is some new law, new regulations came, this automatically becomes what? Automatically becomes the high risk areas or high important areas. Again, it will help you for the scope defining. Now previously all these things used to be done by whom? Auditors. Now AI is helping you. Okay, next thing is what? Control selection. Which controls you should be reviewing, right? So AI will, you can say, I can take an example over here. AI will highlight specific specific access controls specific access controls for sensitive data, for sensitive data as a key audit focus, right? Next thing is it will also help you with the timeline creation. As I've told you, we have limited time, right? I mean, the auditors have limited time, right? Machines do not. So AI will estimate what? Will estimates AI will estimate what? Task duration, how much time this particular task should take based on historical data, and create it will help you create what? Create a realistic what? Audit timeline. Realistic audit timeline, right? Example, you can take down the example. Predicts AI predicts that testing access controls will take will take 3 days 3 days based on past audits based on past audits, right? I hope it's clear till now. Next thing is audit fieldwork. How AI will help you in your audit fieldwork. Data analysis. Data analysis. AI will AI will AI can AI can analyze massive 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 data sets. AI can analyze massive data sets to quickly to quickly identify anomalies. And I think spelling is ANOMALIES, anomalies, or basically abnormal activities or irregularities. Irregularities. Okay, you can take example. AI can find AI can find unusual unusual login patterns unusual login patterns from a user account from a user account potentially potentially indicating unauthorized access unauthorized access, right? Next thing, continuous monitoring. Continuous monitoring. AI AI continuously monitors monitors IT systems for potential issues throughout the audit. Throughout the audit, you can take example. AI detects a sudden spike. AI detects a sudden spike in failed login attempts alerting the auditor alerting the auditor to a possible attack all right. Next thing is evidence collection. Evidence collection. AI AI automates the collection of audit evidences and basically ultimately reducing what? Manual efforts. Reducing what? Manual efforts. Example: AI automatically AI automatically captures snapshots, screenshots of access logs. AI automatically captures, or I mean, capturing thing we have discussed, in the snapshot, right? Now here also AI can automatically capture what? Screenshots of access logs. Now, right now, what is to happen is, as an auditor, we need to ask these informations, or we need to have a meeting, and then we need to, in that particular meeting, we ask these evidences from the clients. But please show us, these things, or maybe, if you cannot show us right now, please give us these evidences. We give them the list of the items or the evidences, or these kind of screenshots which we need. Okay, and also understand one thing, when you ask the auditee to give you the screenshots, who knows if that screenshots are real, or it is artificially created. Right now it is not a big task to manipulate these screenshots. I can manipulate this screenshot in just half an hour. It's not a big deal. So if auditor, as of now, what is happening is we are relying blindly on the auditees or the organizations that please give us these screenshots. Sometimes the I mean, auditee or these organizations, if they are not complying with something, they can manipulate these kind of evidences as well. Who knows whether they are really complying with it or not? Unless and until you are observing, you are, right in front of you, you are asking them to do that, to show them these kind of thing, and you are observing things. But if you're just relying on the clients blindly, who knows? But right now, with these AI tools, or maybe with these audit modules, which is inbuilt and which is linked with these AI and machine learning algorithms, and these will give you accurate data, right? So right now, it's, I mean, whatever things used to happen previously, all these kind of hiding things will stop. So it's a good news for the auditors, right? So AI automatically will capture what? Screenshots of access logs as proof of control effectiveness. Control effectiveness, right? Now you can also use something known as NLP. What is NLP? Okay, now I'll be discussing, afterwards. The next topic would be, the AI. Under AI, you have machine learning. So machine learning is a subset of AI. Then there is something known as deep learning. Deep learning is again a subset of machine learning, but deep learning is more, I mean, it can handle more complex things as compared to the machine learning. It can handle large data. It can do more kind of analysis as compared to the machine learning, right? We also have something known as robotic process automation, RPA. We have something known as NLP. What is NLP? So right now we'll discuss about NLP here itself, right? So NLP is what? NLP is natural natural language processing. Now, don't worry about these things. I mean, NLP is easy, but do not worry about these things like deep learning and all those. You don't have this in your syllabus. I mean, they have just used one or two words here and there in that particular amendment topic, right? And also in the exam, also maybe they can use this term here or there, but they will not ask you in depth about these things, because we just have overview of artificial intelligence and machine learning in our syllabus, and And like as I've told you that we are covering more than what is there in your amendments, so nothing to worry as such about the coverage part here. So and since these are the amendments, these becomes important, right? So as I've told you, a regulatory change happened. We just discussed one example, regulatory change. So just because a change happened, it becomes high risky or it becomes important. Similarly here also, since these are all amendments, it becomes important, right? And obviously AI is important for you to understand and for you to know, right? So this topic by default is important. So NLP is natural language processing, right? What is NLP and what it can do? Okay, so basically it is again subset of machine learning. You can say it is again what, a subset of machine learning. This focus on NLP focus on enabling machines to understand, interpret, interpret human language, right? Similar to what your Chat GPT, Google Bard, Google Gemini. So these are the examples of what, natural language processing. If you give some input, it will be able to understand and interpret your human languages, and it will give you what, the desired output, right? Now there is something also known as generative AI. I'll discuss that also here. Generative AI. What is generative AI? As the name itself tells you, it is generating some new data for you. You know what? So nowadays, these Chat GPT 4.0 and these tools, what they can do is, if you tell them that I want a picture of this kind of emotion, if you express the emotion to the tool, and if you ask them to create image, and when I say image, I am talking about the copyright free image. Because like as an organization, or as a company, if I want to use some images in my advertising, I need to pay to these companies who create these images. But with these generative AI, it can create copyright free images for you. So new content, it can generate new content, not only image, it can create and generate new text, new videos, right? So this is example of what generative AI. Now again, generative AI is again linked with your deep learning. So as I've told you, all these complex tasks, will be taken care of by the deep learning. It is much more advanced than the machine learning, right? Anyways, so okay, now understand one thing. Now, don't you think so? Right now in Chat GPT 4.0, if we upload a PDF, okay, now that PDF has some, I mean, there is some limitations, with regards to how many pages you can upload, right? But understand, if we upload some data, or even if you copy paste some data, it can give you some meaningful results, right? Like if I ask these tools that what is something new, or something which is incorrect, or something which is with regards to this particular aspect, it will help me to give that kind of output which I want from that particular document, or from that particular book, or maybe document, whatever. So NLP can extract key terms and clauses from the contracts to ensure that they meet regulatory requirements. So when you, as an auditor, when you will be reviewing the policies, you know we have a lot of policies in the organizations, right? So right now what happens is that the auditor, he's manually reading it, and he's manually trying to see if something is like, when that policy got updated, and who all approved, and or like which authority approved that, and what all things, like have they covered everything whatever they were required to cover as per the regulatory, as per the laws and regulations. Okay, so these were being done manually. Now NLP can do these stuffs, right? Don't you think so? NLP can extract what, key terms and clauses from the contracts to ensure that they meet regulatory requirements. Now understand one thing. You cannot use these Chat GPT and this Google Bard, for analyzing from these sensitive confidential documents. Very, very important. Very, very important. You know, do not, like, you might be having access to these confidential and sensitive reports and documents. Do not blindly use these tools. It is not legal, right? Because these these are all third party, or you can say these are all public this thing tools, and I mean these data will be getting stored somewhere, right? So if you directly upload or directly copy paste these kind of sensitive information, it can create a bad impact for the organization. So you cannot do that. Now if you want to use these tools, now you have two options. You can go for what? You can go for internal NLP solutions. Internal NLP solutions, you know it will be like a platform that will be specifically designed for secure data analysis and meet your organization's compliance requirements as well. So it will not be shared, these data, right? So you'll have to build something of like this, right? So but NLP is what I mean. The examples which I am taking is these, the Chat GPT and Google Bard and Google Gemini. I mean, Google Bard is the old name, right? I still call it as Google Bard, right? So instead of uploading these information, because these are confidential, highly confidential, you can use what? You can have some internal NLP solutions for this particular purpose. Or even if you want to use these Chat GPT, first of all you will need to take what? Permission. And second thing, you will need to what? You will need to hide or mask or anonymize the sensitive data. Okay, so whatever sensitive information, for example, maybe you can say IP address or host names, or the maybe the company name, company address, location, customer names, customer details. First of all, customer details and all those things you cannot even think of uploading here, right? It is it is wrong. It is completely wrong, right? But you can just hide these information or mask these informations, these private information, this sensitive information. You can anonymize it before uploading, and that too with the permission, right? So I'm just giving you example of how this AI tool will be used in the audit process, right? So the next thing will be your next phase, which would be audit reporting. So how AI will help you in your audit reporting. Next thing is audit reporting. Okay, now AI can generate report. Oh ho 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 ho. AI can also what? It will help you for report generation. So AI can draft standardized standardized audit reports, standardized audit reports with key findings, and recommendation. Again, the word they have used is what? Draft, not the final. Okay, it will still have to go through the auditor. It will still have to go through the initial meeting. We'll be what? We'll be discussing these findings and recommendation with the management, right? Then only the final report would be made. So these are all what? The draft report, not the final report. If everything will be done by the AI, then what auditor will be doing? Okay. So, okay, and again, this is something again I'll be discussing. We cannot rely wholly and solely on the AI tools for doing this, under the risk and consideration topic. Okay, so AI can draft what? Standardized audit reports with key findings and recommendations. Next thing, it will help you for what? It will help you for visualization. As I've discussed, in the past, that when you are going for the exit interview, when you have the draft report, and when you want to show your findings and everything to the senior management, it's always good to show it in a easy to understand format, a graphical, maybe maybe use of some graphs and some kind of pics and images, so that it becomes easy for the other person to understand what you're trying to convey the message, right? So it will also help you for what? AI will create what? These kind of visual dashboard visual dashboards to showcase audit results, to showcase audit results in an easy to understand manner. In an easy to understand manner. All right. Next thing is your audit follow up. Again, important audit follow up. How AI will help you in an audit follow up, right? It will help you for what? Issue tracking. AI can track, AI can track the status of audit findings, the status of audit findings, and ensures what? Timely resolution. How it will ensure timely resolution? How it will ensure timely resolution? Sorry, ensure timely resolution. How it will ensure timely resolution? AI can send reminders. AI can send reminders for overdue corrective actions, for overdue corrective actions for the identified, maybe for example, access control issues, right? So this is how AI will help you not only in your planning, but also in your reporting and follow up and field work and each and every phase. AI will be helpful for the IS auditors. All right, so the next topic, with this we finished this topic as well. Now this topic, they have given you in the form of a diagram. I mean, it's not in a form of text in your new review manual. They have just given you some basic information, right? And again, we have discussed in depth with examples from each and every thing, right? So next thing is discussion on robotic process automation and the NLP part, right? So NLP we have already discussed, right? And again, there are other things which again I have discussed. I think deep learning also I have told you what exactly is deep learning, right? You need not know everything about what exactly and what. I mean, you just need to know the basic of these things, these aspects. So basically deep learning, it excels at your complex task which involves unstructured data. So machine learning is well suited for data analysis and automation of tasks with the structured data. What is structured data? What is unstructured data? Structured data means it is well organized data. For example, I am creating these amendment videos for you. This is example of structured data. You need not go through the entire review manual of the previous edition and the new edition and look at what are the changes, what all amendments are there. I am doing all these things for you, right? So what is this example of structured data? But let's say if I give you the old review manual, old new review manual, and if I ask you, you do all these kind of R&D stuff, you identify these kind of so this is basically I'm kind of giving you unstructured data and you need to do more work, right? So understand that deep learning is much more efficient, or it is used for much more handling much more complex task as compared to the machine learning. It is useful for relatively it handles what it has relatively simple algorithms, but in case of deep learning it uses complex neural networks with multiple layers. So machine learning can work with smaller data sets, but the deep learning will, it has the capability to work with a large amount of data. And they also discuss some examples, not ISACA. I mean, I'm just giving you in general, okay? Uh, for example, machine learning is good for basic tasks like spam filtering, fraud detection, and recommendations, based on the analysis, right? But the deep learning, it is excellent for handling complex tasks like image recognition, NLP, natural language processing, generative AI, self-driving cars, and all these are examples. where you can use a deep learning or deep learning is used, right? Next thing is what? Robotic process automation. What is robotic process automation, RPA? Robotic process automation. Again, the name itself is telling you it is automating some process. It is automating some process. So you can note it down saying that robotic process automation is a technology. It is a technology that uses software robots. When I say robot, it doesn't only mean the physical robots. It can also mean the software robots, right? Software robots to automate routine and repetitive task repetitive task that humans usually humans usually do on a computer. These tasks these tasks might include these tasks might include entering data entering data processing transactions or managing records or managing records. So let's take one example. So if you are using a traditional accounting software, it's a I'm talking about example of financial accounting software, maybe like Tally, ERP, or whatever, right? So in case of traditional accounting software, what happens is that if I need to pass entry of maybe expenses or maybe payments, I need an accountant, right? I need an accountant. See, software is doing task to a certain extent, but you still need what? You still need some human intervention for routine tasks, for the repetitive tasks. For example, entering the invoice payments, expenses, payments. Now with the help of this robotic process automation, they have the softwares which can automate even these tasks. So if you just need to upload these invoices, whatever invoices in they have a lot of, they'll be accepting a lot of formats, maybe PDF or Excel, or other format .csv file. So basically what will happen is that uh, when you are directly, what to say, importing these documents or these invoices, automatically the entries would be created. Automatically the entries will get reflected in your ledger accounts, or in your trial balances, or in your balance sheet, right? So what exactly thing is happening is that it is automating this process where the human intervention was required. This is also example of what robotic process automation. There is one more example. It is not fully linked with robotic process automation, but you can say you can link here, okay? But it's not an example of RPA. But like even for the customer handling, customer service, right? So previously, like we all know, we need what? We need manual intervention, right? We need to have like nowadays, we the organizations are giving 24 by 7 customer support. So like for example Amazon, for example Flipkart. So these websites, they have what? 24 by 7 customer support. But nowadays, even here also, you will find that they are not assigning manual agents automatically. They will first ask you a lot of questions. Do you have issue or concern? If you say yes, I have issue or concern with regards to which order, so then you will specify, from various list, you will specify this order I'm having issue in. So then they will again ask you what kind of issue do you have. Do you have a refund issue? Do you have order issue? Do you feel the order is defective? I mean the product which you have received, is it defective? Is it not working? Then you click on, it is not working. Then they will ask you, please elaborate more. Then they will also ask you to upload the images. Okay, most of the things would be done by them, and in the end they will assign what, a person, right? And in most of the cases, they will form these kind of tools in such a way that there will not be even a requirement of the manual intervention at all. Everything would be taken care of by these chatbots. So this is also, you can say, kind of example of what, robotic process automation, where human intervention was required. Now it is being replaced by these software robots, right? So with this, we also discussed the robotic process automation and NLP, right? So let's go for the next topic now. These are all small topics. Next thing, next thing is interpretation of AI and machine learning results. Again, we have discussed everything about this particular part, interpretation, but one thing I would like to highlight here, which is very important again, which is given in your review manual, and I'm writing down as it is whatever is mentioned in the review manual. When possible, they have clearly mentioned, when possible, the IS auditor should ensure raw system data raw system data may be obtained for analysis for analysis and checking of AI ML tool conclusions. They are indirectly telling you, do not blindly rely on these AI ML tools. Whenever possible from your end, you also do work from your end as well. Like, you try to ensure what, you try to get the raw system data, for the analysis, and you can even check whether the AI ML tools are giving you the exact results, or the accurate results, or the correct results. So you also do your due diligence from your end. Do not blindly, wholly and solely rely on these AI ML tools. Okay, this entire sentence is straight away I have taken from the review manual. Okay, all right. So this was it. To discuss on this topic of interpretation of AI ML results. Other things, whatever is written, is already discussed multiple times. In the entire discussion. So nothing new. Only this point was new. So I discussed here. Next thing, the last topic. Congratulations. The last topic here in this particular amendment of domain one is AI ML audit risk and consideration. Again, we have discussed almost everything, but I'll just read out things. AI ML techniques have evolved from CATs, computer assisted audit techniques, and auditors should take similar consideration to ensure these are functioning as expected. Oh my god. So I told you, we have discussed this example previously also, that the way we are configuring other application software, the similar way you also configure these cat tools. The auditor will need to give these rule based instructions. So what they are saying is that even if you're using this AIML tool, you try to look for the configurations and everything, the whatever considerations you are taking for these cat tools, same considerations. See, this is the importance of me discussing and taking more time and finishing with the cat tools. Otherwise I could have just because honestly this amendment is hardly 2 or 3 pages in a review manual. I could have discussed this amendment in just half an hour, and I could have finished it. But then I thought, no, I mean, I cannot be able to teach this topic unless and until I have to link with the cat tools, right? So they are saying similar consideration to ensure these are functioning as expected. When auditing AI ML implementation, the following should be considered. Testing adequacy. Testing AI output might lead to questionable results or audit findings. Auditors need to ensure that tests are thorough and supported by substantial human-led verification as well. Okay, testing is also needed of these these AI algorithms, right? So AI ML systems are often proprietary. Again, we have discussed this thing in the past. These are proprietary. These are, not shared with the other organizations because of the reason, simple reason, what it is having, what it is having internal data as well, right? And internal data are what? Confidential, sensitive. You cannot share these data in the public domain, right? So making that documentation scarce, and even if it's available, it is not sufficiently detailed for a non-expert to understand, right? So they are also telling you what all the issues you can face as an auditor. All these things we have discussed, so quality of training data. The data used to train machine learning algorithms must be accurate and comprehensive. Two things: accurate, correct, comprehensive. It should, I've told you, we should not have what? Statistical bias. Now you will understand, why we have to discuss those three example categories of, AI bias. It's not a part of a syllabus, but it is required to, understand this comprehensive word. It should take, all possible permutation and combinations, all possible scenarios, right? This ensures the algorithm can handle both common and rare scenarios effectively. Inadequate training data can result in the algorithm generating incorrect outcomes. If it is generating incorrect outcomes, your decision will go wrong, your recommendation will go wrong as an IS auditor. That's a risk, right? If you are blindly relying on these tools to give the recommendation or to give the advices, and if there is some quality issues with these algorithms, then your decision, your recommendation, your advice will also go wrong, right? That's why, what they always say, I don't know, I should be discussing this over here or not, but there is something known as security by design. There is something known as privacy by design. What is by design? They always say that, try to build security, from the start itself. Try to think of privacy. Like, for example, we are having data privacy regulations, right? So when you are building a website, when you are building any software, when you are developing a software, try to look for these privacy concerns, privacy issues right from the design phase itself. For example, if there is a website, the website should show, whether the website will collect the cookies. So many of you, if you visit any website, so sometimes you see these kind of thing, accept all cookies, reject all cookies, modify cookies, right? So this is what? This is the consideration of data privacy. And when they were building the website, that time itself they thought about these things. So it is called as privacy by design. Similarly, when you are writing down the codes, the developer is working on the source code, that time itself, think of the security aspect also. That again is an amendment, we'll be discussing in domain 3 and domain 5 with the topic of DevSecOps, right? So what we are trying to say over here is that the way we are having security by design, the way we are having privacy by design, similarly, you also have something known as what? Ethics by design. This AI ethics by design. So which will take care of all these biasness, which we have discussed. The systemic bias, human bias, statistical and computational bias. So you also have something known as AI ethics by design. So, in other words, what they try to say is that do not try to go for the rectification afterwards. Do not, say that, okay, even if the AI tool is giving me the biased result, I can rectify it afterwards. No. By design itself, you think of security. By design itself, you think of privacy. I mean, I'm just giving example of the security by design and privacy by design. I mean, so similarly here also, you by design itself, you think about the ethics. Do not, try to do the rectification afterwards, right? Next thing, reliance on machine outputs. There is a strong inclination to trust the output of AI systems. However, this trust should only be upheld if the AI's accuracy has been rigorously tested. Very important, right? And confirmed across relevant scenarios. Next and the last thing is ethical and bias concern. Again, I have discussed again and again. Employing AI tools which are developed by humans can introduce bias and ethical concerns stemming from human judgment and stereotypes. This requires careful consideration and management. So with this, we finish the entire amendments on domain one, and I have covered each and everything, whatever was there in the amendment thing. I've covered everything, right? So thank you for watching.